Get ready for the broverload.
I'm Nathan Thompson. Joe Biden. Joe Biden. Oh, and the Earth is flat. This dude thinks the Earth is flat. For me, blah blah blah. A brain coach. Oh, the battery's dead. Oh, bro. Like you. Hey, bro. Where are my AirPods? I was like, bro. No, bro. Bro. And I'm like, what, bro? Like, I let you, bro. He knew. Cool story, bro. So I'm like, wow. I literally never saw the dude not drunk, bro. Like literally ever. Okay. It's like, dude, I gave it to you, bro. Get a effing life, bro. Bro. Ha ha ha. Cry me a river, bro. Oh wow. Are you what a psycho, bro? Ha ha ha. Later, bro. Later, bro. Ha 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 ha. Oh what a psycho, bro. He said, have a nice bro. Ha ha ha. You gamma B. Ha ha ha. I said, I'll pray for you, bro. Shut the F up, bro. You ha ha ha. Ha ha ha. He's but bro, ha ha. What a weirdo. I don't call the cops. They wear pentagrams on their chest and they can only have 105 IQ. I'm not a big fan. Hey, bro, Austin's such an idiot. I'm like, what? Because I got kicked off PayPal, right? What? Are you kidding me, bro? You know, bouncing golf balls on hammers and juggling. He takes a little SpongeBob doll and starts hitting it. What? Bob is like the OG, bro. What a loser. You going too deep, bro? Dude, this is the surface, bro. Dude. Like, that's not okay, bro. This doesn't add up. It's a bad look for the flat earth. I will press charges, bro. Don't make me do this, bro. The bromance is over. Much love, bro. You know what I'm saying? You know what I'm saying? Like, bro. Oh, I'm Nathan Thompson. Like, bro, like, calm down, bro. Like, all right. And I'm getting bumps all over my stomach, bro. And, like, they were smashing me, bro. They were feasting. That is his identity, bro. I'm Nathan Thompson. I'm effing Nathan Thompson. I am Flat Earth. I'm the best Flat Earth activist ever. Flat Earth is nothing without me. What a cool story, bro. He was in prison for literally nothing, bro. You know what I'm saying? And I'm like, it 10x, bro. I'm not exaggerating. Like, cool story, bro. When you see the rainbow in entirety and in completion, it's physical, literal evidence that the firmament's still there. Rest assured, the Earth's not about to flood, bro. You're good. But please stop talking crazy in the chat, because I will continue to expose you. Like I said, the clip is only half empty, bro. Geo, bro, like, loved me, bro. Like, loved me. I gave Geo the first bone he's ever had. Just get out. Just leave, bro. No one cares. Memorize alternative things, Mr. Brain Train. Mr. Smart Genius guy flew out to LA and put on a duck suit and stacked toilet paper saying it was going to go to the moon, bro. Purposely misspelled the most important word, bro, to shut, bro. Doesn't add up, bro. Something doesn't add up. Something's fishy here, bro. Yeah, whenever I was like, dude, if you don't stop talking crazy, we're going to have to fight. He would just take off all his clothes, bro. Like, what a weirdo. Thanks, bro. Much love. I need a safe word. Keep taking that higher road, bro. It'll come back to you. Honestly, it feels disgusting and filthy. I feel like I need to take a shower.
Hey, bros. Welcome. Sorry. Welcome to Tunesday night. I'm your host, MC Tune. Bro. That's broverload, and I didn't know who made it, but Harnold in the chat says it was him. Absolutely genius. Love it. Bro. Anyway, tonight we are going to be going over a flat earther's attempt at calculus to apply Gauss's law for gravitation to an infinite plane and see how well he did, and we will compare it to how somebody that actually knows calculus did it as well. But I will be doing it with Sea Lion Prime, who has a stronger backing in calculus than I do. I've done calc, but it's very rusty. So it turns out you don't need a whole lot of calc to implement email RFC specifications. And Tim Davidson says, when I was a teenager, I was broke and stuck in a dead-end job, but after years of working on myself, I'm no longer a teenager. And Melodic Lyrics says, to be fair, integrals are hard. They are. And if you haven't done them for a while, they're even a little more difficult. So anyway, I'm in the Discord server over on the Globe Gangsters. How are you guys doing there? I don't know if you can hear me or not. That sounds great. Do you have the guy's video? You want to play it, or I can either way. Okay.
Right at the end, just to set the stage, it says, the calculated radius serves as a conceptual tool rather than a suggestion of physical reality. He just left that in there. So he didn't even try.
He didn't try to take out what the AI dropped in there?
No, not at all.
Wow.
I mean, it's like the same thing, there's so much wrong with this to talk about. So I don't know if you want to. I could share and then we could go through it that way.
Well, I'll try. I'll share my window and see if the audio comes through. Hopefully it does.
Sounds good.
Right there. All right. Do you see it in Discord there?
Yes.
Okay.
Yes, I'm able to see it.
And then I'll let's see. All right. So here it is. It's 2 minutes and 57 seconds. So if you want me to pause it, just let me know. Here we go.
Professor Steve, and today we're going to be going over flat Earth calculus, specifically how to apply Gauss's law to derive the thickness of our flat Earth.
Is the audio coming through, and is it loud enough?
It is very quiet for me.
Yeah, it's not loud enough to hear.
Unfortunately, that is as loud as the video goes. He does not have it very loud. I'll see it. I don't think. I don't know if I can boost it anymore, but I'll give it.
Can you turn on subtitles?
Yes, I can do that. And give me a second here. Yeah, I have the audio. I can turn up a little bit there to you, but I'll turn on subtitles too. I have here you go. I have on my side, I have an up compressor on my audio, so it does boost it to my audience, but I turned it up for you guys too, so we'll see how that goes.
I want to show you my calculus textbook from my first year of university. I show this to you so that you know that I actually do know what I'm talking about and not this.
Is that a little better?
Yeah, we could just pause there. I'm not sure that having taken Calc 1 is enough for him to know what he's talking about. But he does have the textbook. So, props for having a calculus textbook in the house.
I mean, I went to the Goodwill down the street last week and bought a college algebra textbook. So therefore, that is credentials, right?
Yeah, definitely.
Absolutely.
You should send it to Witsit and see if he's able to use his 160 IQ to quickly work through all the problems in it.
Yeah, well, it's well known that he is he's good at math. He has a competence. Well, what did he say? Doesn't matter.
Different from your typical flat Earth video. As a man of science myself, I am firmly rooted in all the laws of math and physics. Science and math is how we can confidently know the Earth is flat. So I hope you stay and watch this and try to understand it. There are 6 main points that I broke it down to. So if you can address those points in the comments when you make one, that'll make it easier for everyone to reference this whiteboard and kind of see what you're arguing about.
Okay, so just for reference, he has 40 subscribers, 49 views on this, and a total of 6 comments. And none of them address the content. So it hasn't been a very successful video so far, but we're hoping for him.
Problem with the Gaussian surface? Do you have a problem with the integration? So let me know and we can work through this.
Stop there for a second. Can you pause it there for a second, Mike?
Sure.
It's just funny how he says, do you have a problem with the Gaussian surface? Do you have a problem with the integration? As if no, there's wrong here. It's all good, and you shouldn't have a problem with anything. But we're going to see there's a lot of issues. So go ahead.
law states that the gravitational flux over a closed surface is proportional to the enclosed mass. Now, mathematically, it's expressed as an integral. Now, this is really good for us because we're dealing with an infinite plane. That's one of the reasons why we use calculus. It allows us to solve quantities and deal with infinities. So right up here is what we're trying to represent. We have the infinite plane and we have that radius r. That's what we can determine.
Hold on a second. Oh my gosh, the radius r of the infinite plane.
Yeah, so he's mixing up a couple things here, Mike. We could talk about it in more detail.
Yeah, okay.
You notice, oh gosh, he keeps getting in the way of his whiteboard.
Yeah. Well, all right, we'll keep going.
What we got is a uniform gravitational field. We're going to use a pillbox Gaussian surface. Now, the reason why we do that is the formula is well known. So you can't really argue about this. Now, it's expressed as a dr. So we're still dealing with calculus at this point. But we can apply Gauss's law right here on that infinite plane to get the conclusion that the gravitational acceleration is equal to 2 pi the gravitational constant times the surface mass density. So what does that mean? We can solve for the surface mass density, and we end up getting a final answer right here. Now, the final part of this is the mass over an infinite plane. Again, this is another well-known formula. You can't really argue about it. So we're going to use the constants, the mass of Earth, the surface mass density, pi r2, and you solve for r, and you get 9,000 kilometers. So what that means is this r right here, that is 9,000 kilometers, meaning the total thickness is 18,000 kilometers.
Oh my gosh.
If you want the downward vector of 9.8 meters per second, which you do, because we want an accurate flat Earth model.
That was it.
That was it. So if you pull up his the page, I posted it in the chat. Let me post it again because the chat's moving kind of quick. Of course, Chad has helped us with some infinite as well, as always. Oh, Tapioca Weasel's here. Okay, Mr. Weasel, you will definitely have speaking permissions.
Which chat?
The live stream. I'm sorry.
Live stream dash chat.
Yeah.
Okay.
So Tapioca Weasel, I don't know if you know him. He is a PhD in physics, Mike.
Oh, well, does he have a PhD in flat Earth Scientology, like he does, like Alonzo?
I don't know.
Dr. Alonzo.
Yeah,
my favorite part of this. Sorry, go ahead, Weasel.
None of them have a PhD in this because they don't have like a model to have a PhD in.
Well, no, he gave himself a PhD
for school.
Yeah,
I mean that's a bold move. That's what Carl Baugh did.
So, I'm gonna post. I have a PDF as well here. So 1 second. Sorry. Weasel, initial reaction. It was totally legit, right?
I'm looking at the words on screen, and this is it's one of the better facsimiles of an argument, I suppose, or but what am I the more I look at it and the more I read it, I'm trying to that's not how that works.
Yeah, so he made a couple mistakes here.
You're just taking this equation. I don't think that equation at the top is right.
The integral of GdA.
So that one is. So Mike, yeah. I sent you a link in the live stream chat. I put together a little PDF with
the Gauss law plane.
Yeah. Mm-hmm. Yep. And it goes through from a couple lecture notes, some of the derivations. So he did a couple things. Well, the AI did a couple things wrong here that he didn't catch.
Wait, are you accusing him of not doing it himself, but instead having AI do it? No flat earther would do that.
maybe if he did it himself, he wouldn't have written the calculated radius serves as a conceptual tool rather than a suggestion of physical reality. I mean, that kind of kills the whole argument, right?
It does suggest that it was AI that wrote it. Okay, here I have up
Cool.
on the screen here you sent here.
Yeah. So this is it in a nutshell.
I'm most impressed by the vertical radius there.
Yes.
Are standing in for height.
Yes.
Yeah, that
You noticed that the capital R.
Yeah. No, actually, like now that I look at this is like it has too many things right to
just a sprinkling.
be
Yeah, there's a
anything
sprinkling.
else. But like, look at this thing at the top right, where he the point is that like all of the downward vectors are perpendicular to a common horizontal. Like that is completely contradictory to the entire like idea of what a Gaussian surface over a sphere is.
Well, this is over a flat plane though.
Oh,
Yeah.
okay, that would work, but then you wouldn't have a gradient vertically.
Well,
No, you don't. And
well,
that's gonna
there's
be an
a
issue
little
here.
problem there, isn't?
Yeah, and then I'll post to you as well where that's going to be an issue.
And for those wondering, a gradient would be that the magnitude of the downward acceleration varies by elevation. So as you get farther away from the surface of the Earth, in reality, the downward acceleration reduces as you get higher. But in the example that he's using here, the gravitational acceleration or the downward acceleration would have to be the same if it's a flat plane of gravity. So this is all an actual application of real physics. Gauss's law is real, and it is possible to do the calculations for an infinite plane of a homogeneous mass having a specific downward acceleration. So it is a little bit counterintuitive to think you can have an infinitely large plane that would have a finite amount of downward acceleration. But this is a well-known, well-explored concept.
It is exactly analogous to an infinite plane of charge, which is like the prevailing assumption that you use over the majority of the area of like a parallel plate capacitor.
Yeah. So
wait a second, Weasel. Are you saying that gravity is equivalent to electrostatics? Checkmate, Globey.
No, because
analogous, he said.
I heard
it
the
is analogous. They both obey Laplace's equation.
Like a good flirt, instead of hearing analogous, I heard the same. So checkmate. All right, so this is a PDF. This is pretty useful. So this goes through first, the law of gravitation, universal gravitation constant, and then you can get here the derivation of G, the familiar value. So this is all. I think this should all be fairly straightforward. G being the product of the two masses divided by r squared. And then big G is the, gravitational constant, which is what Cavendish originally was. Well, I guess he was trying to measure the density of the Earth, but Cavendish was the first to derive a value effectively of G, right?
As a side effect of his work.
Tomato.
Fair enough. Okay. So, then you can...
Hold on. The reason it's tomato is because they already knew the size of the Earth as a roughly spherical object, which is why it gives them, the mean density. Because, none of what Cavendish did made any sense on any level on a flat Earth.
Correct.
In my opinion.
So this is the first piece. So this just derives G from Newton's law of gravity. And then if you want to keep scrolling, Mike, we can get to the part about this source does a good job explaining the Gaussian formulation. So this is, I'm not sure the best way to explain this in layman's terms, but this is basically a derivation. So if you go down, there's a bit of explanation here. So we take an integral. And so an integral, essentially we're just taking a limit of sums in some sense over a surface, some closed surface. So in this case, they say sphere, cube, cylinder, whatever the case may be. We can also then apply it to a plane, though. So if you look here, though, there's a nice description. It basically says Gauss's law for gravity says we're given some mass, which may be of arbitrary shape. Now imagine constructing an imaginary surface around mass m. Divide the surface into infinitesimally small squares of area dA. Draw a unit normal vector that is perpendicular to the surface at the square's location. Let g be the acceleration due to gravity at the square. And then take the dot product of g and the normal at that square, multiply by the area of the square, and then sum up all those products for all the squares. The result will be negative 4 pi g times the total mass enclosed by S. Whew. So this will work for a variety of surfaces. And then if you go to the next step, this is a derivation for the plane. And then we're going to run into essentially the issues that Alonzo did in his original derivation, or what the AI did for him. I'm not sure if he did a couple AI mashups or how he got to the Frankenstein's monster that's presented in his video. But basically, so this one is a plane. So he's mixing up two things in his derivation. The plane here has zero thickness, and therefore its mass is just given by the mass over the area. So if you go down all the way to the bottom here, there's more calculus here, and then if you scroll up a bit, yeah, you went past it. Equation 22.
Whose document is this? Did you write this? Who wrote this?
Oh, this is, if you go to the top, Mike, I forgot. Hold on, I can pull it up on my side, so you don't have to scroll all the way to the top.
Right.
It's by.
You're just referencing this to fill in. Yeah, that's what you're doing. Okay, I wanted to clarify.
Yeah. This is just to reference the background on how things are done properly, so that we can then break down all of his mess ups. But if you see here, so G equals 2 pi G sigma.
Yep.
Where sigma is the density. Basically, what we find is that the area essentially cancels out, and the distance also cancels out. So the acceleration due to gravity of an infinite plane of mass is independent of the distance from the plane. We're going to find out that that's a big issue in a minute, but let's get back to his derivation to figure out that it doesn't even work the way he wants it to work here, and his whole math is complete garbage. So do you guys see what the issue is with step 4, sorry. So he actually, step 3 is sort of described correctly. The pillbox Gaussian surface, that's just a particular type of surface that we can use for that integration step that we talked about. But notice what the issue is here. G equals 2 pi G sigma. So he's assumed an infinite plane of zero thickness, but he's now trying to use it for a plane that has non-zero thickness.
You can get away with that.
Oh, you could?
Yeah, I'm pretty sure basically you can, actually. I'm not aware of a reason why. Mathematically, it seems, because I'm pretty sure that all of this is linear. So, like, if you were to just have, if antimatter didn't fall down, if it did the opposite thing, which we figured out that it doesn't, but that's a whole different topic. It's a fascinating topic. Anyway, those would cancel each other out, just like in a parallel plate capacitor. When you're not in the middle and you're on the outside, those will cancel each other out. So you can sum these things over, and they don't have to be infinitesimal. If they had to be infinitesimal, the entire point of making a two-dimensional problem would kind of break down, because it wouldn't actually generalize to 3 dimensions. So I think that's okay that it's not it's super thin. It does have to be the same thickness as you go across, but it doesn't have to be. Is that what you meant?
Well, if you go back to the PDF, Mike, the other one that I sent you.
Yep.
So this is the derivation for a infinitely thin and then infinite plane. If you scroll down,
Oh,
I've put in.
Turtle.
hold on a second. I've got a cat that has just showed up. Just a second. I've got to show the grumpy orange cat, and he'll give you some messages.
Look at this little dog.
Oh, yeah, and the dog comes in, torturing the cat who's hissing.
You said
Aw.
donkey.
All right, there you go. Okay, thank you. All right, sorry for the interruption, people.
Oh, no, good.
Oh my gosh, I got orange cat fur on me now.
Hey,
All right, sorry, Discord people, you're gonna notice all of the orange cat fur on me. All right.
So maybe we can try to reconcile this, Weasel, because if you scroll down, oh sorry, Mr. Weasel or Dr. Weasel.
You can just call me Weasel or Tap
Right,
or
so-
Bandy.
So this is the derivation that Bislin presented, and I checked it out against some other sources, but I guess the only real difference is if you scroll down equation 2.
Yep.
Do you see how the thickness and density come in there?
Yeah, because you multiply those to get the total mass. Like and so if you dug into the Earth, you would see a gradient then in this model, but like if it was infinitely thin, you would just see it flip sign. I mean, it's obviously not infinitely thin, so.
Gotcha. So there's a few things that go wrong for him, I think, though. So,
But I think it's important here that the differentiation here between the infinitely thin one and one that has an actual thickness to it.
correct.
Right. So this equation 2g equals 2 pi g is at rho and then b, right? Rho is the mean density.
So that would be his 2r, 2 capital R in his derivation. So if you go over to his figure on the right,
on the top right.
see capital R there? I'm not sure why he's dividing it into 2 here.
What does the R mean?
So the R is the height. That's supposed to be, I think, it's supposed to be a cylinder with a radius R.
Yeah, the pillbox
That is infinitely long.
The pillbox can
Yeah.
be a cylinder that's infinitely big or not infinitely big. That's why he's like, I'm going to use the pillbox, right? Which he doesn't know what it is. A pillbox is a cylinder. And
In my experience, the pillbox was actually a rectangular prism. It was for the flat. It was the Gaussian surface for the flat thing. But you're correct. Every pillbox I've ever actually used has been a cylinder. So
yeah. So but it's infinitely wide. So whether it's rectangular or circular, it doesn't matter. It's infinitely wide, but it's got a certain thickness. So the R that he's putting it, right? He's drawing the picture R, but of course the AI that he used didn't have a picture. So he's interpreting what that R is, I think.
So here's the biggest problem, I think, here. If we go back to his esteemed journal page, the other
This
one.
one, yeah.
Scroll down.
Okay.
So he has 2 different things. So for an infinite plane with surface mass density sigma, that would suggest an infinitesimally thin one.
Okay. Which works for things like electrical charges.
Yeah,
Because-
and supposedly it has some applications as well, like real life applications. Like you use that as a simplification, but the thing that's weird here, there's a couple things that are weird. So I believe that an infinite plane with non-zero mass density would have infinite mass. Does that math check out, Mr. Weasel? If it has a non-zero density, an infinite plane would have infinite mass. I mean, just thinking about it
I
simply.
don't hear Mr. Weasel.
Yeah, I seem so cut out.
Okay.
Yeah.
sorry, no, I was muted. Yes, it would. But that is a problem for a more subtle reason. The infinite amount of mass is not intrinsically a problem, in my opinion. I think that the universe is infinite, and I think that there's probably an infinite amount of mass in it. For example, so the problem with an infinite plane of mass that's self-gravitating is stability. That's not a stable solution. If you have a perturbation away from it, you're gonna conglomerate into chunks that are gonna become spheres.
Interesting. Okay. So when the asteroid hit and yeeted the dinosaurs into space off the dirt pizza, it would have formed into a sphere.
Well, yeah, but I mean, the dinosaurs, they probably would have gotten like their jetpacks out and gotten all mad and like started a war, and it would have turned into a whole thing.
Okay, well, if you scroll down, I think that the practical problem that he's going to have is this. So if you read the results and discussion now, we had just derived that sensibly so, that a infinite plane with non-zero density has infinite mass. Now let's read this section. So the radius, blah, blah, derived from the calculations, suggests that if Earth's mass were spread uniformly over an infinite plane with the calculated surface mass density, a circular section of this plane with a radius of approximately 9,000 kilometers would encompass Earth's mass.
Now he switched the definition. He switched the definition of radius from how thick it was to how wide it is.
Yep.
Right?
Yep.
That's fair. I think probably if I were to plug in all of these numbers, this would actually work out.
Well, we're going to do that in a little bit. We're going to do that in a little bit.
But what he's saying is well defined. You could have a finite uniform slab of mass, and it would above it, if extended infinitely, or if you're close enough to it that you can't tell the difference, you're going to have a completely uniform gravitational field being sourced from that mass. And I would bet then if you do a circular chunk, like, I mean, they literally show the math up above. So I'm thinking I can't put in these numbers.
Yeah, but isn't the issue here, so correct me if I'm wrong here, but this struck me as weird because he's saying, we'd said earlier that an infinite plane of non-zero density should have infinite mass, but now he's saying if Earth's mass were spread over the infinite plane, wouldn't that give...
Oh, okay, yeah, so that sentence is self-contradictory. Earth's mass could not be spread over that plane and have a mass density other than zero. It would have to have the mass density that they were talking about earlier. So that is a contradiction. But
okay, yeah, that makes sense, because so I think the issue that he did here is I don't know what AI mashup he did, but this is maybe AI gore that we would expect when you try to get an AI to do math. It's thinking about the mass being infinite in one context and then finite in the other context. Because I think otherwise, if you took the assume a uniform density of the Earth, and then you have an infinite plane of that density, and it doesn't really matter whether it has thickness or not, it's going to reduce to the same thing, essentially, right? It'll get a constant gravitation based on the density, whether it's density per volume or density per area. It doesn't really matter that much. But the issue here is now, and then if you took a certain radius over that surface, you would get Earth's mass. That's what he's trying to say, I think. So if you have an infinite plane and then you take a finite cylinder of that plane,
that's exactly what he's saying.
You get Earth's mass.
Yes.
But he gets it.
I don't know why they're giving us that number. That's not so I read that and I'm like, yeah, okay. Other than that that badly worded first sentence, I am following this. Your point is okay. I don't. What is the point?
Well, all right. So Clive Wells, I'll put it in the chat here. put this in the YouTube chat. He says 2L equals G over 2 pi G rho is the correct formula for the depth and the Gaussian surface is a pillbox, which is finite volume. The cross section does not matter.
Yes.
Okay.
The cross section doesn't even have to be uniform on a Gaussian surface.
I got a couple flies in the room here. You know, if you clap your hands over a fly, it'll jump into your hand, but I didn't get it that time.
If you clap your hands over like above one?
Yeah, above the fly.
I did not know that.
The
Is that a
motion
real
will
thing?
scare the fly, and it'll jump up to intercept your hand.
You mean if it's perched on a thing?
Yeah.
Okay, that's.
But then if you scroll back up to his whiteboard, there's another weird thing that I noticed. So do you see his M equals sigma pi r squared?
Yeah, down to number 6.
Yeah, again, he's mixing it up because that's not the radius, that's not the thickness of the plate, that's the radius of the circle.
You can integrate out one of those dimensions though. Like if you integrate out, the vertical dimension, then suddenly, boom, now you're fine.
I like how you're taking it so seriously.
I have an infinite amount of patience because I've only done one actual flat Earth debate ever yet, so my patience has not yet worn out. And also, I've been wrong a lot, and I'm very willing. I'm willing to let them be wrong about a whole lot of things and still be like, their conclusion is completely, categorically, on every level, absurd and unwarranted, and demonstrates a profound lack of understanding. Because that's true. It's just that you can get individual things wrong along the way that might seem obvious when you're looking at it in retrospect or something. The Earth isn't fucking flat. What?
So, all right, yeah. I want to review for the YouTube audience because they may not know exactly. Again, I want to review what this is about. The Gauss's law for gravitation can be applied to a surface. Typically, a surface is something that's enclosed. So, a circle or enclosed means like it's. The surface doesn't just have rigid edges to it necessarily. It has some specific shapes that you can deal with. So a cylinder is one, a sphere is another, and there's others. And typically when you see the pictures of them, it's some sort of a potato shape. You're like, what the heck's that? Well, it's a closed surface. And then you define a very small square or rectangle of that surface. You just pick out a little piece of it and you say, all right, let's just calculate over that. But let's actually make that little thing, that little part, infinitesimally small, which is what calculus is doing. And then we can determine it for the entire, you sum them and you determine it for the entirety of the surface. So you can do that then for a sphere of a certain mass and figure out the actual, the downward acceleration. Well, guess what? That's what Newton was doing. But also you can do the same thing for an infinite plane, which is a special case of a closed surface. So that's what is happening here is just the calculations for an infinite plane of uniform mass of a certain thickness. And there is a finite gravitational acceleration that would come out of that. So the infinite plane society, even though none of them tend to actually have this position, the infinite plane idea actually sort of almost a little bit, but not really works. There's some significant problems with it, but anyway, and so he's doing this and trying to apply this Gauss's law for gravitation as a way to support the idea that gravity does exist for flat Earth. But it doesn't really get you there, which we haven't yet got to, but we'll cover in a little bit.
Well, I guess
We
the
hinted
thing
at
that I want to ask to Dr. Weasel is, I just love saying that. I'm sorry. If so, isn't he mixing things up though in terms of what he's solving for? So if you go back up to the whiteboard and you just we look at the entire whiteboard.
Okay.
Yeah, if you could scroll out so we could see the whole thing. So he has capital R, which is half the height of a cylinder, but then he's solving for little r, and isn't little r the radius of the cylinder? I'm confused. I don't understand what he's doing here.
Yeah, so yeah, well, the little r is definitely the radius of the cylinder. The capital R, it makes sense for it to be the height of. I thought it was a plane. I didn't think it was, because if it's a cylinder in that case, then that means that the mass of the Earth is spread along a line, not a plane. So I think that's just the distance above the plane, which is, you don't use R for that typically. R is used in a context where the concept of radial or radius makes sense on some level. And sometimes it's very generic. Like sometimes you'll just call a random point in space R, with a little vector thing on it.
Yeah. Well, but he's trying to drive so he's got it all mixed up here. The radius of flat Earth, which would be, I think he's just got it.
Oh yeah, if he's trying to propose a radius for the pizza planet, then that doesn't work, and that doesn't work for a reason that has been described on many YouTube videos that I have seen. Simon, Vsauce, yeah, exactly. I think Vsauce did one, and the thing is, most flat earthers don't believe in that model because of
Vsauce,
partially of that reason.
Yeah. So to review that, Vsauce said, without really knowing their background like we do, but he said, well, yeah, if the flat Earth was a disk and gravity existed, which he didn't take their gravity no exist bro position, then the pizza of Earth that would have a certain thickness, well, it would have its center of mass in the middle of the Earth, somewhere south of or down from the North Pole, and then that would be the direction of gravity in general. So as you got out toward the edge of the disk, then your vector of gravity would be angled more and more down until you got all the way out to the, walked over the edge. Then you could stand sideways on the edge of the coin, basically, if it's like a coin,
So I think I know what he's trying to do here. I have a very technical diagram that I sketched out on paper. Oh God, my lighting is so bad.
Are you going to share it?
Yeah, I will. I'll upload it. The lighting is so bad here that's I have a shadow of my hand on the paper. Skill issue. 1 second. I'm going to put it in the live stream chat. Photos. Gosh, come on. 1 second. So I think I know what he's getting at, but he's mixing. He seems to be a little bit confused. So hopefully we can help him out here a little bit. So I just posted it. I think this is what he's modeling. So do you see how there's or maybe I could start a whiteboard. Is that helpful?
The drawing you did there?
Diagram? Yes.
Yeah, well, I'll put it up on my screen here. There we go.
So you see how it's infinite in both. Okay, let me add to it. 1 sec. Hold on.
I don't know if it really matters. I think we're getting a little too deep into this one.
Okay.
Because I've got Walter Bislin's application of it.
Yeah, I have that in the PDF I sent you, Mike. And then we could maybe talk about what the issues are. But I think this is what he's trying to get at, is that the pizza Earth would be this little circle in the middle of this infinite plane.
Okay.
And he's trying to derive the thickness, but he's actually deriving the radius of that little pizza in the pizza box, as it were.
Yeah,
but he's mixing up a lot of things
for no real reason. Well, I think we're giving him a little too much credit.
Yeah,
right?
fair enough.
This is clearly AI generated, and he is copy pasting without understanding what it is that he's copy pasting.
Yes.
And the AI is hallucinating answers
Yeah.
here because there is no actual answer for it to go and get. So unless the AI has had an opportunity to synthesize an actual application of Gauss's law in this for this problem, it might not be able to do it because AI isn't thinking. It doesn't have critical thinking skills. It's not rational. The only thing it can do is put together things that it's seen before in similar patterns. And if it hasn't had that, then the only thing then what it will do is it will make things that look like what you asked it to do without knowing it's right or wrong.
Indeed. And I think there's a lot of that going on here. But I don't understand why it would even matter to derive the radius, because the radius here is arbitrary. If it's really infinite plane Earth, then who cares? Like, is he saying like he's trying to derive like the AE mapped radius? Like, I have no idea what he's doing. But that's not even that. So this number is, I don't know if you have any other thoughts here, Dr. Weasel, but to me, this 9,000 kilometer number is pretty meaningless.
Yeah, I agree that it's meaningless. What that is that that's the number that if the Earth was a giant quarter or a giant pizza, like that is the radius it would have to be with that amount of mass per surface area. So you got to integrate out that dimension. But it has to be infinite anyway. So like, what's the point in giving us this number? This number doesn't mean anything.
Yeah, and I don't think he knows that.
No, they don't. Like that's the thing. The reason that I'm one of the reasons I'm willing to be like, they're technically right on this very narrow way that they're framing it, which is in fact the way most of the time that they are framing it without realizing it, because in this case, it really does look like they've copied from ChatGPT. And ChatGPT does a much better job at science than most flat earthers.
Yeah, at least it looks sciencey.
Yeah, well, frankly, I use ChatGPT at work, not to give me the answer, but to like basically like it's much more efficient sometimes to ask ChatGPT a version of the question first, because one, it's sort of like the rubber duck technique, where if you explain the problem to a rubber duck, you kind of realize the solution. And it is sometimes very good at giving you that one little bit of information that brings you over the edge in figuring out a solution.
Got it. No, that makes sense. I use it a lot as like the initial stage of code generation.
For
like
so good at that. Yeah.
For like writing tests and stuff like that, like very unit tasks. But anyway, Mike, I guess if we want to get past this point to why this wouldn't work, if you go back to the PDF,
your PDF
from that I sent you, yeah,
this one here.
So this is Bislin's kind of more correct derivation. And this is him actually calculating the correct thing, which is the thickness.
Yes.
In practice, it could be, but basically the issue here is going to be that G is constant. And then I can send you
small g,
issue.
Right? Yeah.
Small g, correct.
Yeah. So for those following along, so this right on the screen right now is from Bislin. Right. Mm-hmm. And you can, there's a couple things that are quite severely wrong with Alonzo's here. Whether R is the thickness at the bottom here, this 9,000 kilometer, or the radius of the disk. Well, if it's radius of the disk, it's horribly wrong, because you can't cheat navigation. You can't cheat the distance between latitudes. If it's a circle, then it's got a edge to edge disk size of 40,000 kilometers. You know, If you're going to put up any sort of rough approximation of a map, you don't get anything else. That's what it is. But if it's the thickness, then that seems a bit thick, because the radius of the globe is 6,371. So this is an infinite plane. That's if that's what they're talking about. And actually, he's saying that it's 2R. If it's capital R, that he's swapping between cases, I don't know. Maybe not. Maybe the AI is confused. I don't know. But then it's talking about 18,000 kilometers thick, which is larger than the actual radius of the globe, right? The size of the globe. So then you're sitting there with a little bit of a problem, because he's proposing that the infinite plane has a larger thickness than the globe has as a complete diameter, which would just the smell test would tell you it would have to have a larger gravitational attraction than the Earth, the globe Earth. So
Yeah. So the thing here is he seems to be getting things. He's mixing up a lot of things here, and because if you go back to his article, as it were, the AI output that he's calling his article.
Yeah.
So if you go to methodology.
Yep.
So he's solving a finite section of the plane with radius r has mass equivalent to Earth's mass. That makes sense.
Okay.
So that would be a circle of radius r of an infinite plane with no thickness. But then he's saying that radius is the thickness. So he's all kinds of confused here. Okay. And then
and of course he's got the picture of not the infinite plane. He's got a picture of Gleason's map there on the screen.
Yeah. Well, that's one of his pieces of merch.
Yeah. This is just him trying to sell stuff. I mean, bilk the flat earthers. I approve. Go ahead. Bilk them. I wish he had a little more following, right? These videos only get like 40 views. Somebody should totally, pick them up and bring them into their tribe.
Challenge accepted.
Yeah. Okay. Let's go back to the Bislin's treatment of this.
Yeah, so he derives a completely different value, and he is actually deriving the thickness properly here, because what he's doing here is he is deriving, basically, if you look here, the equation G equals 2 pi G times rho B. I believe, so that should be correct. I think I double checked it. Clive says he's using half the correct value for the density. So I don't know if this passes the sniff test for the more physics astute people. I did a little bit of background on this, but you can see that his number is completely different, and it's calculated completely differently as well, because what Alonzo was actually getting from his AI was the radius of that little disc in my drawing, not the thickness. And then he's misinterpreting it as the thickness, I believe. But anyway, I think we can. If you go down, so there's a couple interesting things.
I'll just say this gets a little better on the sniff test, because then that puts the thickness at 4,200 kilometers, where the radius of the globe is 6,300 kilometers. So it's smaller than the radius of the Earth. Being an infinite plane, you'd expect that. So just as kind of a rough back of napkin type of idea, right?
Yep.
All right.
Oh, and then this is actually an interesting application. Also, I sent you, Mike, in the chat. There's something called igf.pdf.
Yeah, I got that.
Which we can talk about if you have that. That's going to talk. We can talk about next why a constant gravity is a big problem.
Yeah.
Constant G. But the interesting thing here, and we have Shubil here, so I'm not sure if you could add any color here in terms of like the gravimeter and like gravity anomalies. But basically, I think this Gaussian pillbox and Gaussian surface methodology is really useful for. Oh, Blue is here as well. We have another person. I'll give you Blue a 1 sec. Let me just give you the speaker.
that is, right?
Yes, indeed. So the I don't know how to say that. I'm not going to pronounce it because I always pronounce everything wrong. But if you see this here, this is a application of what we're talking about, and this is actually used in geophysics as a model for gravitational anomalies. So this actually has an application. This idea of like a planar model, and then deriving like a subset of the planar model to get like plates for the purposes of gravity anomalies, which you can then compare to use as a model for what's basically as a way to represent the data that you're getting from gravimeters. But I guess we could move on, and unless there's anything else, I feel like we've kind of shown why you don't use AI as a end-to-end derivation without understanding the details.
Yeah.
But
Never. Categorically never.
yeah, bad things happen, and he got very confused. But so this one is very cool. It's something I found recently. So this is called the International Gravity Formula. And I have two sources that are mashed up here. So Tuna, I can send you these as well, like the actual raw sources. But this is the problem with assuming a constant gravity, is that you can see here, so there's two curves. On the left-hand y-axis is the meters per second squared, or the local acceleration due to gravity. On the x-axis is the latitude in degrees from the equator to the poles. And you can see two curves here. The first curve, which is dashed, is what the gravitation, the acceleration due to gravity would work out to, just based on the oblateness of the Earth.
How it would vary at the surface, right?
Correct.
At sea level,
yes.
Right? Yeah.
Correct. At sea level, yes. And then in the second curve, this is a application once we apply rotation, which creates, another force that will be part of the effective gravity. So my understanding is that there's a gravitation that then converts to, at least that's how the USGS defined it in the documents I looked at. Gravitation defines a force of gravity on the Earth, and this force of gravity produces G, a local G, which is shown here in the International Gravity Formula. And this second curve shows the effect of rotation and oblateness. And so the formula is given below. You can decompose the coefficients into oblateness and rotation as a function of latitude. And then if you scroll down further, there's a couple other terms as well. Oh, so here's what I was talking about. This is where the plate model comes in. So this is the so-called how would I even pronounce that? I don't know. The B gravity anomaly, let's call it.
My 13-year-old mind reads it as a booger gravity anomaly.
Okay, well, we'll call it that.
But I've heard PhD Tony pronounce it correctly, and I do believe it would be pronounced with some sort of a French type accent. So it's like bouger. But in my head, it's just booger. I can't not see it.
I would say Beaujeur, but it could be Beaujeu.
Just a 13-year-old
or
right
booger.
here.
That works too.
Inside of a all right, sorry.
Oh yeah, and then if you scroll down to the table, this gives a nice representation of the
right here.
Yep. You can see the effect due to altitude in the second table.
Yep.
At the equator, and the effect due to latitude at sea level. Now, I'm not sure how to combine those two per se, but basically, the gravity cannot be a constant, and there's a fairly significant variation based on latitude. Yeah. Less so with elevation, but nonetheless notable. So that right off the bat, if his whole thing is he's being scientific and empirical, this completely invalidates his model.
Indeed.
But as ChatGPT said, if he had read his own paper, the calculated radius serves as a conceptual tool rather than a suggestion of physical reality. So the lesson of the story is, boys and girls.
Is this in the conclusion of it?
Yeah, it is. Right where it says gravitational studies. The calculated radius. You see that sentence
The
there?
calculated radius serves as, yeah, there it is. Yeah, he either didn't read it or didn't understand when ChatGPT added this, what it meant.
Yeah. So, I mean, yeah, it's completely bunk, falsified by the international gravity formula and the variation of local G as a function of where you are on the Earth. I guess Shoebill or Blue, do you have anything to add? You should have speaking roles. If you don't, let me know. And you should just have to leave and rejoin the channel.
So for, while they do that, for reference, there is the necessary variation that must happen in gravity based on latitude and elevation, and there is the then measured amount, and they are in agreement with each other. And there's a 53-year-old survey called the International Gravity Standard Network, IGSN 71, from 1971, thus 53 years ago, that has standardized the measurements and the methodology for measuring the downward acceleration using gravimeters, which are basically just very precise accelerometers. And so there's thousands and thousands of measurements that are publicly available for anybody to go get. And I have on my website a couple links to it. And I will put the link to, my gravity predictions is the this is so I use a rather rudimentary way to calculate the predicted downward acceleration. I intentionally kept it at really 9th grade, probably algebra. So like to do it correctly, you would need to take the vector of the centrifugal force, which isn't straight up, and except at the poles, it's only straight up at the poles. So when you're at 45 degrees north, well, that vector is 45 degrees from straight up, and when you're at just shy of the poles, it's just shy of horizontal, but of course its magnitude trends towards zero at the poles as well. So that was one of the trade-offs, and I'm like, well, I'll just let that be a trade-off. And I'm still better than 1% for most predictions to measurements. Anyway, so I give my methodology for the kind of basic way to do it, and I think Walter Bislin has a better methodology, but of course it's a little more complicated, and I intentionally left it not super good for the challenge, so that I did for flat earthers, so that it's not even that good of a prediction, and no flat earthers even attempt it, because they're just dumb and wrong. So anyway, I think in here I give a couple links to it, to some of the methodology, some of the measurements of it. So.
And I don't know if you want to talk about the so a flat earther. Well, sorry, I don't want to be bigoted. They're not a flat earther. They're a bev earther. Presented me with a formula for their formula that they derived in their spreadsheet for gravity.
Wow! They tried.
Yeah.
Amazing.
They tried. Yes.
Was it even close?
Well, it gives a maximum predicted value of gravity at the poles of 9.95.
Okay.
So it's a little bit off.
Pretty high.
and he thinks it has something to do with standard atmosphere as well, but I for the life of me, I can't figure out how.
Bev does?
No, this is their crack engineer.
I mean, you do have a non-zero buoyancy component.
I see. So is that maybe what he was getting at? Because
like if you have a precise enough scale and you weigh an object, and then you pump all the air out of the room and just watch the scale, and it's precise enough, the amount of gravity will increase because there is some buoyancy in the air.
Well, but gravimeters do their the
Yeah, they
measurements.
do it in a vacuum.
Yeah, in an evacuated chamber.
Like falling corner cube gravimeters, god damn it, they do it in a vacuum. And I'm an atomic physicist, and I'm specifically in the area of atom interferometry, so I prefer atom interferometric gravimeters. And those also work in a vacuum, as it turns out, because
That's a good thing that vacuums aren't reality then,
Well, I mean,
natural phenomena. So we're
they
good.
don't exist in nature. Therefore, you can't do
that's
it.
impossible. You got you have to have you got to have a container to have a vacuum, which is also not true. I can you zap a bunch of atoms really still and trap them in the middle of a vacuum chamber, and you have a localized pressure density that's way, way higher than the background, and there's no material barrier. It's categorically not a thing that you need.
Do you have some papers or like a demonstration of that, Dr. Weasel?
I was literally looking for one. The thing is, I'm trying to find a picture of, every time I'm at home, I always think, oh man, I got to remember to take this data set when I'm at work. But I haven't done it in a way that I can look up easily on our lab's wiki, which is the thing that I'm I will try and get it.
Okay, because that would be excellent. That would be a nice way. I've been using the Siberian High as a way to wrangle flat earthers into silence on the whole container thing, but that one's a little bit more abstract. Showing it in the lab would be kind of a nice showstopper, I think.
Yeah. Dropping an ultra cold atom cloud and watching it as it falls and expands does two things. One, it gives us an excellent measurement of the temperature of the atoms based directly on measuring the momentum distribution of the cloud as a whole. And two, because they're in a vacuum and they're not subject to any other forces, if you're careful, they fall at G, exactly at G. And so we use them to calibrate our magnification. It's super handy.
Nice. And what is the latest stuff? So I know that the Royal Navy is working on a new system for their submarines to basically use gravity anomalies as a way to navigate. Is that something that you're familiar with?
Yeah. Oh my God. Yes. So when I was my first year in grad school at the University of Colorado, we were visited. Our lab was visited by people from the Navy who they weren't using it for gravity anomalies, but you totally could. You totally could. They were going to use it for magnetic anomalies to try and detect subs and whatnot. And I was like, I can't believe that we're at a day and age where if you zap some atoms with lasers in the right way, you can detect maybe, because they were going to put it in a plane, you could detect submarines at the bottom of the ocean by flying a plane over them and zapping atoms with lasers. This is amazing. It's a real thing that people are trying to do.
Okay.
Wow.
So,
well, the submarine chasers from Airborne, they were also using LiDAR of sea surface trying to detect the bow wake. So even though a submarine may be 100 meters down, by moving forward, there'll be a ever so slight hump in the sea surface. So that was also being used in these airbornes and magnetic detection. If they could, see, a bar magnet, tooling along.
Cool. Sorry, Mike. I think you
yeah,
had something to say?
I'm excited. I apparently Fusely Jerry has a $10,000 challenge. I'm anxious for it to either be a real challenge that will net people $10,000 or for an additional confirmation of the second law of Flurf. So maybe he can post it. You know, the official rules, the acceptance criteria, the objectively verifiable means by which, you know, it'll be judged, the independent judging part, you know, rules, that kind of stuff. I don't know. Maybe I'm being hopeful.
Yeah, that would be something I'd love to see as well.
Yeah, link it, Jerry. I have I'm still sharing that. Let me stop showing that. I've got a little something that, let's see. Share device, I think. This one. Wrong one. I'm going to share my camera, the P1000, of course. There it is. You see the P1000 there? Fusely Jerry is talking about real surveyors. He's talking about real surveyors. So here's a book, Surveying, 8th edition here by Francis Moffat and Harry Bouchard. And so I would say that they're probably real surveyors, being that they're well enough established that they've actually written a book on it. But here is how real surveyors deal with reality, right? They have right here. Let me get that in focus. See that level line right there? I hope all of the wannabe Flurf surveyors are paying attention here. We've got level line right here. It's curved. See that? Beautiful line. And that the horizontal line, it's only horizontal, it's tangent to this point here, right? And it keeps going and it diverges from level as it gets farther away. Isn't that amazing? You've got these two level lines here. And then the datum down at the bottom, the datum is also curved. So Shoebill, what would it be an example of a datum?
The North American vertical datum of 88.
There you go.
Which and the datum line is an orthometric, not necessarily the ellipsoid, because you have two different height systems. You have an ellipsoid height system and an orthometric height system. So contrary to what many people say, or in casual conversation, mean sea level is not a datum specifically, because sea level varies. That's why individual charts like at ports, they all have their own mean lower low. So orthometric datum, which is based on a singular point in all of North America, and then that datum line would reflect the geoid. So that's not a modeled mathematical surface, that is a measured surface, and they have all sorts of gravity surveys across the country that do a pretty good job in the centimeter range.
All right, thank you.
Because if you use a survey instrument, it's oriented to gravity, then you're measuring orthometric height differences. And if you're using electronic means or satellite means, then you're getting ellipsoid height differences, and we have databases to equate the two.
Awesome. Thank you, Shubo.
One more thing while I have this book out. Here's the preface of the book here, right? And on the, is it this one here? Oh, hold on. Oh, wrong page. Hold on. Maybe not. There it is. Okay. Chapter 1. You see that? Let's zoom in a little bit. This is a little treat for the flatties that get confused about planar surveying. So we've got the surveying operation of leveling takes into account the curvature of the spheroidal surface in both plane and geodetic surveying. So leveling takes into account curvature in plane surfacing. The leveling operation determines vertical distances and hence elevations and differences of elevation. So when talking about planar surveying, vertical measurements take into account the curvature of the Earth. So when flatties are like, oh, planar surveying works for 100 square kilometers, 100 square meters, and then this many, or miles, they say 100 square miles. And they're like, then they go, in 100 miles, they swap to linear from square. In 100 miles, there'd be this much drop. And they don't take into account, but of course they do, because in both plane and geodetic surveying, vertical measurements include the curvature. So anything that would deal with elevation changes or drop due to curvature is included in plane surveying.
And in planar surveying, yeah, that only applies to north and east or X and Y. It's a simplified grid to remove scale factors to get to a projection. But elevations are completely outside of that realm. It's just X and Y northeast. Elevations are uniform across the whole spectrum.
I thought I'd show you this while it's out. You see this? This is a dip compass. And the red one is north, the blue is south. Flat earthers sometimes get confused. They think that that a compass only points one direction. It points two, north and south. So anyway, here's how you work a dip compass. You make it, you get it so that the bar that you can't see it from the side, but of course it's lined up underneath this, and then you rotate it. And when you rotate it, then it pivots so you can see the angle of the magnetic field. Now it's difficult to see from the camera up here. And if I lift it up, it'll wobble around. So what I'm going to do is I'm just going to pinch this right here, and then I'll twist it back up so you can see it. So this is the angle of the inclination here, and you read the angle here of the magnetic field here where I am in Minnesota, about 45 degrees north latitude. So flat earthers severely misunderstand the magnetic field of the Earth. And since they misunderstand it so much, and then they talk to themselves about it, it's an actual complete mess listening to them because they have no clue. So anyway, I got this to bring to Antarctica. Hopefully, if I can safely transport it on the plane. And then test. So flat earthers, if they're correct in there's just the North Pole in the center and everything out is the South magnetic pole, completely not even understanding that there is a South magnetic pole in the ocean south of Australia. They don't know that. They're that dumb. Ignorant, not dumb in that one. Anyway, the south end of the compass on the globe needs to point down in Antarctica and south of approximately south of the equator. And on their proposed model of the flat Earth, the north end must always point down, just decreasing as you get farther from the center. So we'll see. Yeah, beating that dead horse. PhD Tony had asked to be brought in. I see he's in the chat here.
Yeah, Tony, thanks so much for joining. You might need to leave and rejoin to get speaking perms. I just granted it to you. You just leave and rejoin the VC.
And
you should have it now.
He can probably correct us on the pronunciation of booger. He has corrected me in the past, and I've proceeded then to forget about how to pronounce it correctly.
It's bugay.
Bugay. Okay.
It's bugay. So I just shared 3 papers on cold atom gravimetry in the chat. There are some others that I happen to have. Really? Okay. Peters et al. This is actually the technology that I'm helping to code for at the moment. So this is this is really my job. I'm trying to design satellite orbits for cold atom gravimeters.
Satellite orbits. Oh, so that
Yeah.
this would go in a satellite.
Yep.
To measure.
And so the question is, what is the most efficient sort of configuration of instruments for constraining the for obtaining more information about Earth's gravitational field, and in particular, the people who have awarded the contract, they're a private company, so they want something that's marketable.
So, all right, strontium atom interferometry with an optical clock transition as a gravimeter and gravity radiometer.
Yep. Yes. So what they do is, as was being described, they sort of they gather the atoms and they supercool them with lasers in a magneto-optical trap, and then they put them into the measurement chamber with a velocity of about with a very low velocity, so a velocity of a couple of meters. Over 20 seconds or something like that, so a fraction of a meter per second. Then they hit them with lasers that break them up into two bodies, one that propagates upwards, one that propagates downwards. Then they recombine those and look at the change in wave function once they've been recombined. And that Bose-Einstein condensate is a material where all of the atoms in the cloud share the same wave function, so they all propagate according to Schrodinger's equation. So the evolution of the function tells you something about the acceleration that they've undergone during the measurement observation. Also, as C-Line is mentioning in the chat here, there are multiple examples of measuring gravity using neutrons. In particular, I think most recently Nezvizhevsky has used what's called quantum gravity capture states of neutrons. So you use ultra cold neutrons with a very low velocity, and you propel them into a very narrow gap between two surfaces where they're moving so slowly that they can't enter either surface, so they're sort of reflected backwards and forwards. And it turns out that their position in that gap is quantized, so there are only a certain number of positions that the neutrons can be in.
Yeah, it's like a matter wave Faraday interferometer.
Yeah, exactly. And so you can look at that technique has been used also to look at gravitational effects and quantify them, and to confirm that our modeling of these processes is correct.
Yo, PhD Tony, you and I should talk offline or whatever, because I literally I work in a lab at Stanford doing atom interferometry with optical clock transitions on strontium for gravitational wave detection. So,
right. Well, that would be really interesting, because while I talk with I know a bit more than the average layperson, but I could really learn a lot from you. So that would be really cool.
I could probably learn a lot from you too. It's a field with a lot of different, making constraints on different types of apparatuses. Because what you've described, I mean, basically is exactly the same thing fundamentally.
Yeah.
So the only difference that we're doing is we're building a giant tower that has a 10 meter, and at Fermilab we're building a 100 meter long version, where there are multiple self-contained atom interferometers. That are all on a single long baseline and can be addressed with the same laser, and thereby negate the several main sources of noise.
Right. Yeah. Yes, that is the main thing. Is sort of, there are a lot of practical problems that need to be overcome before you can deploy these on satellites. Of course, reduction of noise.
But they're pretty good. Oh, I was looking up my favorite one. Absolute airborne graviometry. They put it in a plane, and flew it over Iceland.
Right.
And it was amazing. I think this is the one. Like they flew over a mountain and they watched the gravity get stronger. They flew it east. They watched it get weaker. They flew it west.
Yep.
They watched it get stronger because of the Edavos effect.
Yep.
It was amazing.
Yeah, so they are really interesting. It's a really interesting and exciting piece of technology, and there's a growing series of sort of applications. Some people have suggested it for aircraft inertial navigation. I'm not sure if the sampling rate is necessarily high enough for that purpose, but
it's getting there.
Yeah, so there are a lot of very exciting sort of practical applications, particularly having a high sensitive quantum inertial sensor is really good if your GPS gets knocked out, or if if there's spoofing of GPS signals, or you become independent if you've got a ultra high sensitivity instrument. And similarly, you can do what you were doing earlier with gravity anomaly maps, but that technology is actually quite old. So yeah, they were doing that before. They were doing that on submarines before they developed gravity gradiometry, and gravity gradiometry.
Any good corner cube dropper, I think they're counting laser fringes, right? So if you have the fringe count over time, you can still do a gradiometry measurement.
Yeah, you can.
That baseline.
I mean, sort of the main thing that the main thing about the gravity gradients is that they have, they behave in characteristic fashions as you're approaching a mass, and it will tell you sort of where the mass is relative to your location as you watch the gradients change. I'm not sure if they were using. I think they were using actually electrostatic gravity gradient sensors, which are the same style of sensors that we used on the Gauss satellite, which was sort of in the early 2000s. That was a satellite put up to do gravity gradient measurements. By the
so is the idea of an electrostatic measurement that but what is it? I'm not familiar with that.
Yeah, I'm not familiar with the guts of the instrument, but I think it's sort of, in essence, you've got a proof mass in the instrument, and you're applying electrostatic charge to you're measuring its response using electrostatic sensors.
So you're probably modulating it so that it's going back and forth, and then as it moves, that will cause a phase shift in that response. Because anytime, a word of thumb, by the way, if you're planning on becoming an experimental physicist, people who are listening, anytime you can, try and turn a measurement into a frequency measurement, because you can measure frequencies really well.
Yeah.
Super handy.
It's one of the things that we're most precise at. Anyway, Sealine was just saying that he wanted a couple of papers on this subject. One of the ones that I would recommend is Hu et al. I shared it in the live chat for the live stream chat. Is that the right place to drop those links?
Sorry. We have dedicated channels. Let me. This is related to probably what I could just we put it in the physics channel, I guess.
All right. Okay.
Yeah, that would be the easiest because the chat is moving super fast at the moment.
All right. Yeah, but the Who et al. One is the one that sort of really interesting to me, and it probably contains the best illustration, I think, of what's going on.
I also posted here. I can post it again. The absolute airborne graviometry with the cold atom sensor, the one where they flew
Right,
over.
okay.
It's super cool.
Awesome.
Yeah, it's a really exciting and fast growing, and there are lots of applications. You know, people are working towards various styles of spaceborne. However, I'm becoming a little bit concerned that maybe single satellite missions aren't actually competitive anymore. But we'll see.
Very nice.
I'm working on a project from while you're talking, from what's his name here. He had some genius stuff. Fearbuck is a flatty, right? Sea Lion.
Yes. Fearbuck is. I believe he is the worst flat earther on Discord. I nominate him for that.
Okay. All right.
He has this habit of. Oh, I have to find his celestial navigation.
Did he
submission.
do it?
He AI generated it, and the 3 stars of his fix were Orion, Sirius, and Star A.
Oh, that was him. Oh, genius!
Yeah.
I love that.
Yeah.
Maybe he could come in and learn us all on how to do cell nav because he's so good at it.
Well, he's in the VC right now. I could unmute him.
Man. All right. Well, let's make sure that the rest of you get your stuff wrapped up here.
Just before you do that, I'd like clarification on what you mean by the worst flurf, because there are a lot of axes along which you can measure the quality of a flat earther.
Lowest tier of arguments.
Lowest tier of arguments, okay.
Yeah,
because I would argue, I would make a persuasive, I think, argument that Oakley and Quantum Eraser and Santos are, as people, pretty much hard to beat.
Yeah.
I don't know if Santos qualifies as people.
I'm pretty sure he doesn't, but I was being generous.
Yeah, that's good of you. That's big.
Anyway,
of you.
I was listening to this, and Sea-Line was just saying, "Oh, do you have any papers?" And I go, "No, I've got some papers at home." So
awesome.
Just as soon as I got on, I just wanted to share them with you. And I'll stop interrupting and let you guys get on with your conversation.
No, thank you so much, Tony. I really appreciate you stopping in and just sharing those papers and your thoughts, and hearing the 2 PhDs in physics nerd out to the max. So, but here's the there's 2 things. The first one, which was funny, that Doofus posted at 10:32 my time, is his edit of Wikipedia, which was just hilarious. So he edited the page on a level optical instrument to say typically not effective when used with a spherical surface. Which, how would you even test that? Would you have like a big sphere somewhere and then, oh, he ran away. He left the VC when I said I would unmute him. Oh, that's surprising.
Oh, that's too bad.
Yeah. He always says that he wins debates elsewhere, and then he always runs away when you try to debate him here.
Oh, is that like the guy that like his girlfriend goes to a different school?
Yeah.
Okay.
Yeah, exactly. Just like Rakia's flat earth measurements go to a different school, you know?
Ah, yes.
But here is 1032 for the humor of the chat. This was his, first he said it was a legitimate solution to the challenge. And you'll notice that there's a few things wrong. The coordinates are just between -10 and 10, so I'm not sure what that's supposed to be. And then we have 3-star fix on a flat earth model. Orion, Sirius, Star A. So it's obviously AI generated.
I'm going to get this up in, there we go.
Yeah, it's worth showcasing.
So this is absolutely genius. I mean, this is groundbreaking stuff. Orion, by the way, in case you're wondering, Orion is not a star. Orion is a collection of stars. You might call it a constellation. Sirius is in fact a star, and star A is I think it may be something in a comic book.
Yeah, I'm not sure that. Have you given a fix to Star A as part of your challenge?
No,
I've never seen that show up.
None of those stars. I think are in. I don't think Sirius is even in it. I mean, maybe it is. It's a common star for navigation.
So I can't find the other one, Mike. But then the next thing he did is he put it back in the oven. And he had the AI try to generate the latitude, longitude, and he listed a latitude of 150. And he saw no problem with that.
A latitude of 150?
Yes.
All right. So, again, this is groundbreaking stuff for those following along at home. Latitude is 0 at the equator, 90 at the poles, and that's it. You don't get more than 90.
Yep.
Amazing. And this is Nobel Prize stuff here, isn't it?
Yeah, I would say so. Absolutely.
Absolutely genius. Okay, well, I'm
and then when I confronted him on it in VC, he said the flat Earth argument equivalent of it was just a prank, bro. He said it was just a test, but he doesn't seem to say that in this original post when it says 3-star fix on a flat Earth model. Yes, they have Space Pope. They have. For some reason, the Flurfs, they distrust all sources. They will rag on you for using Wikipedia, but they religiously subscribe to ChatGPT. It's a very odd phenomenon.
All right.
Which is the same thing than when, using a theodolite, they go, oh, optical measurement? You can't use optics. And then they have a P900.
Or they're like, it's not calibrated or certified for that. Wait a second. Is the P900 certified for that range of a measurement? Right? Of course not. But they're okay with that.
And they're okay with a sextant looking at a star. How far away is a star? And I'm only talking going 30, 40 miles with a damn, first order theodolite. How far can that see? How far is that good for? I don't know. Polaris?
Yeah.
All right.
I don't know if you guys saw it as well because the chat was moving kind of fast, but this same guy, he goes by a bunch of, he always changes his names, but his name is High Up Level username. And
yes.
He was trying to say that there's no matter that doesn't have a charge, but if you look at 1037, he has a slight problem.
Neutrons don't have a charge.
Yeah, and who is that saying that? Well, that would be High Up Level himself.
Oh, yeah. All right. Well, I have the world premiere of the song by High Up Level called Electric Wave is Coming. So if you'll give me a second here, I will adjust things so that you all can hear it. Let me just test, make sure that my audio settings are correct. Just a second here. I got this. Okay, do you hear this?
Young boy, I grew up on the farm. I'm a country boy, and I used to fuck the cows and the pigs. I used to fuck the pigs, and the cows would come, and I would pat them and look into their eyes.
Did you hear that there on Discord?
No, I don't hear anything.
No.
Oh
dear. Okay, hold on. Let me adjust the settings yet again. I need to look at my Discord settings, make sure that I'm sending the correct audio. What am I saying? To Zoom. Oh, that's why. Okay. All right. Now can you hear this?
boy, I grew up on the farm. I'm a country boy, and I used to fuck the cows and the pigs. I used to fuck the pigs, and the cows would come, and I would pat them and look into their eyes.
Did you hear that?
Yes, I did.
Yes. Okay. Excellent. So, all right.
I'm not sure I wanted to hear that.
Well, that's Santos. All right. There, I gave you the wave file, but I'll play it now. All right. Here we go.
Charge. Electricity is always on a higher pressure condition, but the next wave or electric wave is coming, and in order for it to continue flowing, it has to be pushed out of the way. Electrons, neutrons, protons are all electric charges, and gravity is the equal and opposite reaction, the resistance to the push.
There you go. High up level, amazing
Beautiful.
work.
That's
Yeah.
beautiful.
I hope you all enjoy that.
Oh, man.
Get some nice gift. I love the hillbilly music for them. It's so
Yeah. Oh, so I don't know why I agreed to this, Mike, but I am debating Alan on quantum mechanics on the 24th, Jeranism. So,
Oh wow.
yeah. I'm a glutton for punishment.
Wow,
so.
bro is gonna have some quotes from people and
Yeah,
some
he will.
papers from some fringe scientists that
Yeah.
that probably have some shady methodology and understanding or analysis of their own work. It's gonna be great.
Yes. Well, so there's a couple fun little things, though. So I had been chatting with Alan, and Dr. Bennett had an idea that he posited after the last debate to them that we should do like a pre-debate evidence review. And Alan did agree to that. So we still need to agree on exactly what the terms are, but we'll have to submit our sources ahead of time.
Oh,
The
yeah.
other thing that'll be kind of fun is that we talked about doing more of a regulated debate format rather than the usual kind of opening statement, open discussion. So more of like a modified Lincoln Douglas with like, affirmative construction, negative construction, cross-examination, and then like defined, like we'll figure it out, but
Yeah.
that should make it a little more interesting.
I love the hillbilly dancing.
Yeah.
It's so funny. Is he seriously not here? Where did he go? And oh wait,
He ran away.
who's real flat earther?
Oh, that's Marty.
Is he a real flat earther?
Yeah. That's our pal Marty. But he doesn't look like he's deafened right now. He's the one that he came up with his own hexagon Earth map.
Oh, man, they're creative. Good for them.
Yeah.
Give him a trophy.
Add him as a speaker if he's there.
Oh, and we got man, you got them all here. You got a concaver.
Yeah, we got our pal Glory.
Yeah, that's Glory. Let's see. Can I?
Glory, you have speaking terms if you would like to speak, but no pressure either way. You just
Yeah.
have to leave and rejoin.
Yes. All right. So people are asking, can CC be given a one-way ticket to Antarctica? And the no, you're not allowed to leave trash there. So that's McFlatty keeps trying to convince me to bring him, but no.
I'm just a guy that reads PDFs on the internet.
He's just the guy that reads PDFs on the internet.
I mean, that is essentially what he does.
Yeah, yeah. And has anyone ever heard Fusely Jerry talk?
Yeah, he talks in the VC here quite a bit.
Oh.
He does his he runs his hump or drop script on the unsuspecting nerds, and
I see.
it's quite effective if you play into it. Actually,
Yeah. Well, I mean, we could have a little frosting on this nerd cake here we've had.
yeah. Well, everyone should have speaking terms now, so if anyone wants to jump in, feel free. And if you don't, let me know.
Jerry's not even in the VC here.
Yeah, I don't think he'd come on stream.
Ah.
But I would love to see Jerry do his hump or drop script live.
I haven't heard that. Jerry.
It's pretty basic, but it's surprisingly effective. My favorite rendition of his script though was there's a fellow named Donald C that is on Discord that was hanging out here, and he got jerried for about an hour. And my favorite line that Jerry came up with was, "Do spaghetti, doorknobs, and shoes have triangles?"
What? Was that like he's trying to one-up DMOC?
Oh, well, that was basically to ridicule the idea of a spherical triangle.
Oh.
So he's like, does every shape have a triangle? Does spaghetti have a triangle?
I see. Yeah, I mean, you can draw a triangle on the surface of spaghetti. Of course you could. Ah.
Oh, one other thing. There is a debate this weekend between Lael and Brian Leakey, which Sean is going to host.
Oh my gosh.
Yeah, so. Lael is our resident Mr. Slave defeater, so we are appreciative for Lael. He made Mr. Slave leave earlier, so.
Oh, that's nice.
Good job, Lael. Yeah. Mr. Slave was asking Lael what makes the apple fall from the tree, to which Lael said, usually the apple doesn't fall far from the tree, which Mr. Slave didn't find very funny. Yeah. Hey, what's up, Marty? How's it going?
Oh, I had to deafen myself from McToon here and his endless parading of F ears.
Oh, well.
You are on a server called Globe Gangsters.
Shit.
We all walk around the mean streets of suburban Minneapolis with our bandanas on our heads, carrying pipes, chains. In fact, I have taken a pipe, welded a chain on it, and on the end of that chain, I've welded a hunk of pointy metal. So you better look out.
I heard that someone in your gang had his nickname was Popcorn.
Is that it? Does it end there?
Is that?
Okay. Maybe a laugh track would help. So we'd know when to laugh. No? Okay. Well, good joke, bro. Oh, the Ether Boys. Oh my gosh.
Yeah, shout out to Think Floyd for that one.
Oh my gosh.
Hey, Morty, would you like to ask McToon a question for me?
Oh, sure. McToon, question 1, will you agree to answer a series of questions?
Yes, and the first question has already been answered.
Yes, there you go.
All right.
Take it away, Marty.
Question number 2. Is English your second language?
It is not.
Question number 3. Are you AI?
I am not.
Question number 4, 2-part question. Do you pay your taxes? Do you trust your government?
Yes and no.
Question number 5. Do you now or have you ever worked for any of your government's secret intelligence agency?
No. But if they're hiring, you know how to get a hold of me.
Question number 6, are all these questions retarded?
Hold on, don't run interference, Lil. We need to let.
Are they all mentally challenged like you, Lil? No, they're not all. Question number 6. Do you now or have you ever had a sexual fetish for any of the following? Ladyboys, femboys.
We're not going to ask that one, though. Skip question 6, Marty. Go to question 7.
I'll just say the first Beetlejuice is one of my favorite movies. At least the actress is.
To that, I have to say Dale. Daylight coming, me want to go home.
Did you mean Gina Davis?
No. And
Winona Ryder?
There you go. But I did like Gina Davis's line in The Long Kiss Goodnight as the semi was jumping off the bridge. Great line there.
Sea Lion, I just want to mention to you that Toon is afraid to debate me because I'm the king of the flirts.
Is that right?
All right. Oh, we've got the
and
laugh
Gina
track.
Davis did initially make that famous quote, "Be afraid, be very afraid."
All right. We're off track here. We need the rest of these questions.
All right. Are you ready? Okay. I wasn't sure if that was. If you're good with the rest of the questions, I will unmute him.
Do they diverge off of there now? Do they get like worse?
I think that's the worst one, but go ahead, Marty.
Okay.
Continue the survey.
Question number 7. Will you now or have you ever accepted Jesus Christ into your heart as your Lord and Savior?
I have.
Amen. Question number 8. Do you now or have you ever had a functioning female reproductive system?
No.
Question number 9. I've seen you with your shirt off. You definitely work out. Question number 9.
Well, number 1. Hold on. You have not seen me with my shirt off, but I do work out, and it doesn't seem to have done a whole lot of improvement.
It's only guys like Morty with sexual fetishes for other guys like those guys that are all chiseled and buffed out. So I'm sure your wife loves you, right? Question number 9. Do you believe such a thing could exist as a perfect circle?
A perfect circle? Not in meat space.
Not in deep space?
Meat space.
MEAT?
Yeah, if you've read Cryptonomicon, you'd know what I mean.
I'll have to pull that up.
Okay.
Are you ready for question number 10?
I'm not sure. You'll have to ask it.
What's Earth's shape?
It's a globe.
You know what Neil deGrasse Tyson says?
He says it's a globe.
Do you know what the fox says?
Ha-cha-cha-cha-cha-cha.
Neil deGrasse Tyson will say, there are more stars in the night sky than there are grains of sand on all the world's beaches. Earth's highest tides are caused by the gravitational pull when both the moon and sun align with Earth, pulling her oceans out. If you were to measure the distance between Earth's highest mountain peaks and her lowest ocean lows, it would be but the depth of a fingerprint when compared to Earth's mass size. Earth's shape is not but a globe that you spin on your desk. She is an oblate spheroid, pear-shaped.
All right.
So next time someone asks you, what's Earth's shape? Say it with me now.
It's a globe.
Oblate.
The globe.
Spheroid. Like asteroid.
All right, now my questioning for Toon. Toon, are you
No, I
still-
got one last question
Hold on,
for
Lale,
Toon. Would you like to continue the series of questions?
Does it have more poetry? Because I'm going to pass if there's more poetry.
No more poetry.
Oh, good. Okay.
We have we can skip ahead some questions, or you can give us your favorite number and we can go to that question, or you can actually pick some categories.
How many questions are there?
There's 99 questions and you only answered 10.
Oh my gosh, there's 99 questions and yours ain't the one. Wait, what's that song? I don't know that song. I only know the song from Weird Al.
I got 99 problems and electric gravity ain't one.
There you go. That's good.
Or 99 bottles of beer on the wall.
I don't know if I have patience for 99 questions. Let's jump to number 27.
Well, let's skip ahead. Question. We can. Whenever you're done, you can bow out and let Lael ask you whatever question he wants to, because I know you love him. Let's skip ahead to question number 32. Illuminati confirmed. How many Discord alts do you have? Is this your main?
This is my main. Yes.
You pay for Nitro?
I do not.
Oh, you should. You can boost the servers you hang out in. What do your friends call you in real life? What's your nickname?
You can call me Mike or Toon.
Well, I'll call you.
Sometimes in my band, I am the Notorious PID.
Let's skip ahead to question number 241.
You said there's 99. You can't count. Hold on a second. Oh my gosh. All right.
Oh, you actually, I was just quoting a rap song. We can go to question 93 million if you want to skip all the way to the end.
I wanted number 27.
27. All right. I'm going to go back a few here. All right. Question number 27. Do you now or have you ever drank alcohol to excess or been addicted to any illicit drugs?
No drugs. And I've had on a couple occasions enough alcohol that I don't think I would have been safe to drive.
Yes, and hangover sucks. Right, kids?
I've never had a hangover, fortunately.
Amen. I've been without a hangover for 11 years, and hopefully will never have to have one again. Question number 241. Do you now or have you ever believed in the adverse effects of man-made climate change?
That one is very weird because a lot of the modeling that they did in the 90s seems to have been a little bit falsified these days.
So,
right.
Which Bush was your favorite, HW or just W?
I'd probably go with the son. He was a little
right.
more
Would you have a beer with him?
No, I hate beer. Gross. I'd have a pint of Irish cream with him.
Irish what?
Irish cream.
Irish creme de lime. So this is the next question, McToon. Am I twice your age?
That's unlikely.
I probably not. I don't know your age.
Are you 21?
I'm 13. Didn't you know?
Could I say something?
Of course, Jesse.
Oh, Jesse.
Oh, thanks. Hey, Mike.
Well, I think we have Lael on deck if he can be quick. Lael is,
I only have one question for you.
All right, well, hold on. All right, so let's do this.
You're awesome.
All right, Marty. I think that was kind of going nowhere. Thank you, though. All right, so let's go to Lael quick, and then Jesse.
The one question is: was all of Marty's questions retarded?
No. I think some were interesting.
I got 99. We can keep going.
No.
Okay, one more question: were they all flat Earth tuned?
No.
I got a question for you, Lyle.
No, it's on to Jesse.
Oh, okay.
You have to keep quiet until I ask you the question, Lyle.
I would never ask
him. Go ahead, Jesse.
Mic check. Am I coming through?
Yep, go Jesse.
Oh, good. Yeah. I had a friend. He was an old timer. He's passed away since, but he had worked for in meteorology, however you say that. Working with, they have a lot of like temperature logging stations all over the world, but all over America specifically. That's the ones he worked with. And he did a lot of work in Alaska and stuff. And he said he really enjoyed it, but in the last few years before he retired, it was getting really annoying because the way they were, the places they were placing these stations, and how they would, like, if one station was inoperable, they would maybe substitute data from another station, and the way they were doing that, and where they were placing stations, like maybe near industrial buildings and stuff, they were doing it to try to spike, or to try to make the average temperature go higher, to read higher than it actually was. And so he could see that they were trying to force the results that they wanted, and he didn't like that very well.
I got a question for Leo.
Okay, are we going crossfire now?
But
are you there, Leo?
No, but Leo can't talk until he gets the question asked by was it Terry?
Yeah, that's
right.
Yeah, Terry.
That's it.
Never ask the question. What happens if you never ask the question? I want to know.
Gosh, Michael, just don't let Niall know what's going on.
Well, yeah. So then nobody can ask Leo anything until Terry does.
That's right. Exactly.
So poor Leo's got to just sit there now. You can't break those rules, Leo's. I don't make them.
What's a good question?
What's a good question?
None that you've asked so far.
Yeah, there you go.
Ask me the same question.
There you go.
It is what it is.
Yeah, it is. Yeah. You want me to ask you a question, Marty?
Ask me the same question.
No.
Marty, you ought to show your map. Yeah, there you go.
Is this your map?
This is Marty's map.
Oh man, that's
we're
amazing.
debating the map the next weekend.
I can barely see it.
Are you actually are you totally serial that this is what you think the Earth looks like?
Surreal? What did you say there?
Are you totally serial that this is what you think the Earth looks like?
Yeah, are you speaking some jive there? Am I serious on my flat Earth map?
I'm hot cocoa that's what he thinks it's like.
Well, who's posted this? Let's see what they posted.
That's Carnivore posted it just now.
Oh, I haven't blocked, so I can't see what.
Yeah, everyone blocked, Marty. I'll post it.
That map is.
Did you chop off? Is it a typical map where somebody chops off New Zealand again?
You know what? Australia's lucky to be on that map, all right?
Oh, jeez.
Dude, I just want to mention one thing about my debate.
Wait, Lil, Terry never asked his question.
Yeah, what is going on?
Come on, Lil.
That's it. Lyle just ruined his question.
Go ahead. You were going to ask something about the debate, though, Lil?
Oh, I was just going to tell him that the person I'm debating doesn't know who he's debating, and I don't know the topic until, probably about 10 minutes before the debate.
Okay.
That's the only way Sean G could get a flat earther to debate me.
By keeping it a secret.
Apparently.
Now we got to hope that this flat earther doesn't
find out.
Yeah.
I'm already predicting that once he figures out who it is, if he hasn't already, that he's not going to show up.
Okay. Well, all right. So to answer, I was asking, when I said, are you serial? And you asked if it was jive. What we're going to need to do probably is ask Leave It to Beaver's mom to come and translate to jive, out of jive for you.
Is she going to rub my feet and light my cigar?
Maybe she offers those services. I don't know.
Well, I will answer any question you have once you've completed my series of questions.
There's too many in your series. Thank you.
There's literally 45 minutes worth of questions. And we've only been 15, 20 minutes max.
Yeah, 45 minutes of questions.
No, there's 90 minutes of questions, all right?
Okay. Well, 90 minutes of questions is 150,000 minutes too many. So Yeah.
Can't you just combine all the questions into one question, Marty? That'd save time.
Here, I'll do it for Marty. Derp, 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 derp. Sorry, Marty. I had to.
All right.
Are you not entertained?
We are not.
I think so.
Thank you. Thank you for trying.
I gotta ask this next question, all right?
Oh, all right. Last one.
Question number 616. Have you ever looked into numerology?
Yeah, numerology is BS.
Define a conspiratorial thought.
Wait, no. You already asked 616 the question of the beast.
Shouldn't that have been 666 for that numerology question?
McToon has looked into numerology.
It is 616 is the question
If you
of the
have
beast.
33 might show up.
Don't say his name 3 times.
You need 3 sets of 2 3s. Well, the next question is question number 777, and
that's the question of Striper the band. They're touring. They're on their 40-year anniversary tour right now. But they're not coming.
Are they an 80s hair band?
They're not coming to Minnesota. I'm very sad. Not even close.
What's your God's name? How do you say God in your native tongue?
God. That was hard.
Amen.
I don't know
I like to say Yahweh sometimes, just to mix it up.
I mean, ask Lael that one. Maybe. That might get a different answer. I don't know.
McToon, have you ever, or do you now believe NASA put a man on the moon?
Not just one, but several. Including
many men.
And got him back off, too.
Including Charlie Duke.
Are you a goddamn American?
I am.
All right, can I ask you one final question? It's a loaded one, all right?
You've already asked the final question. It was the question of the beast.
It's like edging. It's over the edge every time.
Oh my gosh.
Are you ready? You know what they say when they say something, right?
Is that the question?
Question number 911.
God.
That's a conspiracy.
All right. Oh, hold on. Did you ask it? Or hold on.
That's it.
I got the laugh track. Hold on. All right, there we go. Thank you for the laugh track.
I didn't hear it. I must have someone muted.
No, I
don't think
YouTube.
I played it.
Do we not have soundboards enabled because someone doesn't know how to run a server?
Well, if you didn't hear the soundtrack of the laugh, that means it wasn't funny.
Oh,
all right.
See, I'm clueless because I went into my Discord settings and turned off the funny board, so I don't hear anybody's funny boards ever.
All right, McToon, this is the final question. Are you ready? Or,
You already asked 2 final questions.
This is the last time I will ask you.
This is like Ozzy Osbourne.
Is anyone laughing at this? Is anyone enjoying this?
No.
Anyone?
In 1990, Ozzy Osbourne had his No More Tours tour. And while I don't know if he has any planned right now, he was touring just a few years ago.
Hey, does anybody know how many tickets they sold for the last Flattoberfest that got blown away?
Karen B probably does.
I meant anybody here.
Well, they were only sold. They weren't sold online. They were sold at the gate. So since they moved to I don't know, a Red Roof Inn's parking lot or something, I don't know. Hardly any tickets were sold.
Oh, okay.
But someone, Dan was talking about. I think it was Dan. Yeah, they were talking about it. They had, I don't know, a Hampton Inn or a Red Roof Inn or something, and they just asked if they could use their back area and they said, yeah, go knock yourself out. And they allowed camping there because the hotel was pretty much full because of hurricane.
Wow.
Yeah, a lot of things Dan says is this total BS. All right, McToon, Do you now, or have you ever believed what
no.
they say the official narrative was for any of the following? The Titanic, Pearl Harbor, the Great Pyramids of Giza, Chernobyl nuclear power plant meltdown, Roswell weather balloon, aka aliens, UFOs, Sasquatch and the Loch Ness Monster, weapons of mass destruction, WMDs, also known as nuclear weapons with thousands of years of nuclear fallout and useless land, dinosaurs, and finally, forest or huge trees or mountains.
You know, I was in Menards a couple weeks ago, and I saw a guy that had a shirt that said "Birds aren't real." I'm like, dude, birds aren't real. There you go.
You ever look at those red ass eyes, though, man? Those red eyes.
I got a relevant question related to Marty's. Is Karen B Bigfoot?
They've never been seen together.
You know, Brenda might be Bigfoot, though. Brenda's might be Sasquatch.
No, you don't need to do that, dude.
I should have phrased it different. Is Karen B related to Bigfoot?
Lil, can you say Sasquatch for me once?
No. I don't say anything for Marty. Question 33. Do you like 33?
I'm going to see Lil at Walmart, and I'm going to kiss his mother on the lips.
And I'm going to mute Marty.
Oh, Marty. That's it. Thank you, Marty. Bye.
Yep. All right.
Go away.
Adios, Marty.
Just like, you know, just the next one is just going to be that one that you just, right?
So Brian Leakey is here. I'm trying to get him to join the chat because he just released a video about you.
Oh, well, let me read a couple things while he's boomering out here. Melodic lyrics says, to be fair, integrals are hard. I already read that, I know, but they are. Mark Beiser says, I hate you a little for inflicting us with that. Oh, the bro overload. Lord Illuminous Pooh says, after a date, the call is so hard. You don't want to seem needy, but you can't wait too long. Middle ground, ring her the next day and call her a slut. Oh my gosh. That's Lord Illuminous Pooh. Boop TV says, this stream is making me feel like a flurf, and I have no clue what they're talking about. So is this the part where I tell them that they're wrong? Yes. Think about that, right? What we were covering earlier was, you know, not super high-end stuff, but it was things that needed a little bit of a background to really follow along. And flat earthers would hear that, and their response is, it's all fake. Math is fake. Can't be real. All fake. Instead of, oh, I don't understand that. And obviously other people do. Maybe I should figure it out. Or maybe I'm not tall enough to ride the ride. Miss Dr. Tapioca, who's been a member for 14 months. Thank you, Dr. Tapioca. Says, got to give the guy whiteboard credit, though, plus 5 points. And then the good doctor gifted 5 memberships. Thank you for that. How are we doing on Leaky? Nothing yet. Nope, nothing yet.
Leaky Watch is in effect, but he has not materialized. He dropped the video, and he has not. He's not materialized.
All right. Sea Lion Prime, that's you, man, says Alonzo gravity thingy debunked.
Officially debunked.
PT Tony, who is no longer in this voice chat, says, correction, flat earthers are not just dumb. They are plenty dumb. Jesse sends the invite. Rick says, a discussion between knowledgeable people. Nice. Lord Illuminous Pooh says, I don't kink shame unless you have a humiliation fetish. Then, ooh, you're into that?
That was pretty funny.
What's the Witsit animation? Oh, he's being etherically displaced.
Yes.
Or is he CGI?
Yeah. Oh, by the way, that reminds me. I think I know. I think I have the model for the ferrocell image of the magnet.
The model?
Yeah.
What do you mean?
Let me find it.
I think Whitsitt in that animation is probably looking deep into his coffee cup caustic.
That was pretty good, Lil. Good job.
I think actually that the multi-circle thing that he likes to post is actually at multiple magnets on the other side of that ferrocell that thing. But that's not what I was talking about. But yeah, there you go. That's a fantastic model. Completely wrong. Doesn't match reality.
But that might be what they're referring to with the ferrocell. I think that's the magnet in the middle.
Oh yeah. And he's like, there's a plane of inertia, which isn't a thing.
Yeah.
Within a magnetic field. He's like, no, it's a plane of inertia right there. That's where we live, is the plane of inertia. The plane of inertia? What the hell is that?
That's Ken Wheeler.
I know it's Ken Wheeler. It's nonsense. And that's how people like Whitsitt fall into it, because they don't have the scientific background to hear the BS when Ken Wheeler says BS.
Well, isn't the plane of inertia really just counter space?
non-Cartesian inertia, in fact. Whatever that means.
Hey, Toon, you should get a debate between Robert Sungenis and Whitsitt Gets It going.
On the globe?
Well, about the flat Earth and, well, Sungenis is a globe earther, but
yeah, and he's written a book, and the book is pretty good.
But he's a geocentrist, right?
Yes.
Sungenis?
Yeah.
Yeah, Whitsitt's trying to go that route.
Yeah, that's one of his options for the pivot after December.
The other one is to take the Third Reich.
That's I think where he's, he might get a little more traction there, so he might be,
He's surrounding himself with people that have that problem, yes.
Oh, yes. That's definitely his surroundings.
Did somebody say Graticule?
Graddies and Zennies, boys.
Oh, gosh.
Graddies and Zennies.
I ran into Dr. Sungenis's son. He was bartending nearby. And when he said his last name, Sungenis, I go, no, not the same Sungenis on YouTube and shit. He goes, yeah, that's the one. I go, and I told him straight to his face, no offense, but your father's an ass. And he goes, yes, I know.
Oh, wow.
And then he told some horrific stories of living in that household.
Gosh.
Like becoming woefully sick and Dr. Sungenis not taking him to the doctor.
That's lovely.
Shit like that. I mean, it was he went off on it for a while, but he was under no false impression that his father was the good guy.
Wow. I like this picture of Whitsitt. I made the claim, you have to back up my claim. Oh, he gets so offended with you if you ask him to back his claims.
Oh, he does. My favorite was in the debate I had with him most recently, where he cited a science fiction author as a source for
oh my god
against the discovery of Neptune. And the quote in that quote, the page that he was quoting from, there's a line that I'll never forget that said, I think it was 1846. In 1846, anyone who knew a sine from a cosine was out signing and cosigning for a planet beyond Uranus, which is just a beautiful sentence, I think.
Yeah. Still no leaky. Oh.
Still no leaky. Leaky watch is still in effect.
All right. Well,
no, I think he knows better than to come here.
What was the nature of the video he dropped?
Oh, he's accusing you of misinformation on gravity.
Oh.
What's the timestamp on that? I was looking, I couldn't find it.
I don't know. So I think he's confusing the equivalence principle with being like literal. That was what I got to, was like he was saying that he had at least something that was clipped there that said that Indio. he said that he had a clip that said that a gravitational field in curved space-time is exactly equal to an accelerating reference frame, which I don't think is quite right. I think it's indistinguishable from the resulting, like the result would be indistinguishable from an accelerating reference frame, but I don't think it's right to say that they're equal to each other. Anyway, I didn't watch all of it, but
it's 8 minutes. I mean, that's 12 minutes longer than anybody should have of Leaky. So, and you know, spreading disinformation and denying their own model. Oh, precious.
Yeah. I love it when they always try to explain our model to us. Like, our model is that there's one, too. That's the other funny part.
Well, yeah. As if the flat earthers don't deny each other's models rampantly, right?
Right. Indeed.
You go find Oakley and Whitsitt not denying each other's models.
Yeah. Challenge impossible.
Throw in Tim Osman Infinite Plane Society, chuck in Santos, whose everything is a tum. But put Vika Draziv in there, you're going to get all sorts of derp from him. They're all over the place.
Lindsay.
All right, Toon, I didn't hear you. What do you think of the picture that I posted?
What picture? Oh, Pi Day is just a fake holiday created by math companies to sell more math? I buy it.
Mm-hmm.
Yeah,
I asked Toon what he thought of it.
I love it. In fact, the other day I bought more math. Hold on. I'll show you the math.
You bought more pi or more math?
Math. Hold on. I got it right here. I got the math.
I just want to know who these math companies are.
Well, I got it. I'm getting to the bottom of this conspiracy, this math conspiracy. All right, hold on. I'll show you.
What's your proof?
Right here, I got it. I'll share it to you. You can see. You'll see just 1 second. We're uncovering this. We're getting to the bottom of this math conspiracy. Look at this. I bought more math. This is what I bought. It's this guy. That's big math right there. And I fell for it. Look at that. It's got numbers and stuff added. I don't know what this is. S145. Whatever that is. Anyway, look at all this. Look at all this math they're selling us. Right? Am I right?
Oh, yeah.
That's awesome math.
But, you know, Whitsitt can do all of that without showing his work, and he was so good at it that his teachers thought he was cheating. So maybe we should tweet him some of the problems and see if he can do them real quick.
After you've read and done all the work in this book, Toon, you should get one on Clifford algebra and see how well you can do that.
If it wasn't kind of difficult and I wasn't already going to be trying to pack everything I could into my suitcase, I'd bring this and have it be the gift that I give Whitsitt when we're there. But when was it published? 1976. There you go.
It'd be no good to give to Whitsitt, Michael.
It'd be no good?
No, it's got no pop-ups.
Have you seen, did I tell you about this interaction with Indio, Mike? I just posted it where he was saying, Bob didn't measure anything, certainly no 15 degrees per hour. He would have had to have been at a pole, right? 15 degrees times the sine of the latitude, remember?
Oh my gosh.
And then there's
Bless India. All right, hold on. Just for the audience. So the gyroscope that Bob Nodell had was a 3-axis gyroscope. And when you sum all 3 axes, you get 15 degrees. But if you have just one axis, of a gyroscope, and there are some one-axis gyroscopes from the same company. You could purchase a single-axis gyroscope, and if you hold it horizontal, that then has a sine-cosine relationship with the latitude. But since he had all three,
he had some really funny takes. I'm trying to find the one where he misread the source that I posted. Here it is, yeah. And he used a funny word. He said, I posted a paper and he said, you didn't read it. See the underlined part? That's not hydroscope precession due to Earth rotation, you moron.
What?
You say hydroscope?
Yeah, hydroscope precession.
The movement of the gravity vector relative to the inertial space as shown in figure 1, that's the underlined?
Yep, and he didn't notice that the first part is describing the angular momentum or the angular motion measured by gyros, and then taking the difference to calculate heading.
Oh.
So he literally debunked. I mean, what law of Flarif is that?
That's the first.
He literally debunked it. Yeah, he debunked himself with the first equation in his screenshot.
I think he really debunked you because the first line right there under the map of the equation says, and for flat or for stationary scenarios, therefore the Earth is stationary.
Naturally.
Yeah, so Kiwi Bush said send the book to the hotel, like ship it. Like I could ship, if I really wanted to, I could ship things to Chile, and then have it at the hotel and then give it to him on the way back or something. But he will also have luggage to bring back too. And if I hand him this book, what's he going to do with it? He's going to throw it away instead of carrying back this book, because what good is it going to do him? He's never going to look at it. Right? I mean, to be real fair, if somebody gave me this book, I'd be like, I don't need an algebra book. I've got plenty of resources to study algebra. So yeah.
I'm kind of curious too. What time zone is the place you're landing in?
So
Antarctica.
Yeah, so we our home base is Punta Arenas, Chile, which is 3 hours from GMT, and they don't do daylight savings.
I'm asking for Antarctica.
And Antarctica is because there's no setting sun, so it doesn't really matter what time you pick. It's kind of arbitrary. So they say, well, let's just keep it consistent with where we left from. It's almost due south, so it's a similar time zone. It probably would not be the actual time zone, but while we're there, the time zone will be GMT -3.
Okay, what time will you land in Antarctica?
I don't know.
It'd be really cool if you landed after midnight and the sun was due south and still above the horizon.
Yeah, so my guess is that we'll probably, because they honor time zones for the pilots, and the pilots have lives, that will probably fly during regular kind of business hours. So we'll probably get there. We'll probably leave in the morning and get there 5 hours later, right? So early afternoon, because then we'll have a whole bunch of it's like a 10-kilometer ride to the actual camp, and then settle into our tents and all that. So it'll be evening with the sun up, still bright, by the time we're like kind of done with all the logistical things of getting there. So.
And what's your prediction about seeing the sunshade?
About what?
Your seeing of the sunshade. You know, when the sun gets tired, how it puts the shade on?
Oh, yeah. Yeah, definitely sunshade. I do plan on giving him the circuit board for the first version of the electrostatic gravity tester that I made. It's the size of a postage stamp. So Whitsitt did not declare clearly that he was smarter than Einstein. That was Marissa that said she's smarter than Einstein.
Is Whitsitt smarter than Marissa? That's the question you need to ask.
He is. Yes. Yeah. That's a really low bar.
Well, asking any flat earther if they're smarter than anybody is a low bar, so.
All right.
Mike, I have something kind of cool I just posted. Have you seen this about the Polynesian navigators and how they used wave refraction patterns to discover islands?
In the rocks? Or no, that's different. I knew that some early navigators had used rocks that had some special polarization.
Oh, that's interesting. So no, this was like they could tell the reflections and refractions of waves off of islands from a long distance away. And that's one of the ways that they were able to figure out
the island. That is
apparently you can also see the reflection of islands and atolls on the bottom of clouds.
Oh. That's really interesting, yeah.
So that all of Polynesian navigation is a very interesting topic.
Yeah.
And they had these stick charts that mapped out where the islands were. So
that's Whitsitt, me. And I would have gotten away with it too if it weren't for those meddling kids. Oh, that's so good. Oh, I would love to have Marissa come on again. She was so hilarious. And Iggy. Oh, Iggy. He watches some of these. Like, he doesn't comment or anything, but he sent me an email a while ago. No comments anywhere to know that he was listening, but he sent me an email referencing something that I had said in a live stream. So he's watching. Iggy, if you're there, let's set it up again. You got to come on again.
You should debate Kyle Adams again.
I am. That's the plan.
I'm so lucky. I want to debate him. I think that'd be a good debate, me against him.
McToon, I got one quick question for you. Are you ready?
You are 4 questions after the final question.
Blue cheese or ranch?
Blue cheese.
Yeah.
Mayonnaise or Miracle Whip?
No, that's 2 questions.
Neither.
Too many questions.
Too many questions, Marty. We're done.
I got questions. I got categories. If you want categories, we can go categories.
I'll preemptively.
The joke is played out.
I'll preemptively.
The joke is played out.
I'll preemptively answer this one. Pineapple on pizza. Yes.
Okay. Yeah.
His last and final question is a hot dog a sandwich?
I hosted a debate on that, and I will just refer you to that.
That's funny.
Oh,
yeah. You want to see something?
Yeah, do it.
When are you
I
debating
want to see
Kyle
something.
Adams?
It's not set yet, Lael. When it's announced, you will be not the first to know.
Oh, that's fine. Well, you should be the first to know because you're the one debating him.
Well, James will be the first to know. Okay. Firmament, omega equals 2 pi over T sub F equals 7.28 times 10 to the negative 5 per second. That's the hertz. Okay. What's the T sub F? 23 hours, 53 minutes. Okay. Yeah, all right. So that's that's about the rotation of the globe. The ether wind, omega A, is a function, right? Of R. It's a function of R equals K sub A. So K is that a constant? Okay. Over R to the 3/2. Oh my. And K sub A is 9.45 times 10 to the 6 in MKS units from Kepler's third law. t squared equals 2 pi squared over gm of the Earth r cubed. Okay. What is this?
This is from Shane's website.
Is this ChatGPT or what? Okay.
I don't know what the hell this is.
Okay, universe. You got capital omega of r equals lowercase omega f minus what's omega f? Oh, that's the rotation of the firmament, he says, or of the actual globe. Minus omega of the ether sub r, right? And then, okay, I'm not going to read out the rest of that formula, but he gives an actual number. R, it's 7.28 times 10 to the negative 5 minus 9.45 times 10 to the 8 over r to the negative 1.5. Oh my God. All right. Above applies to Earth's primary satellites, moon, sun, stars, galaxies. Red equation.
Wait, I think you glossed over that.
What?
Galaxies?
Yeah, galaxies. Yeah, primary satellites are
Okay,
galaxies.
all right.
Yes, of course. Okay. Well, yeah, because everything has to be local, right?
Right. Indeed.
So the galaxies and the entire Vera Rubin and Zwicky galactic rotational problem, that's all just embedded in the firmament. Red equation gives the observed rotation rates and periods in the MKS system. So MKS meters, kilometers, seconds. That's like a predecessor to this SI system. I mean, you can they're kind of interchangeable. Based on R, the Earth distance. The Earth distance? Well, what's R, the Earth distance to what? What the hell's the Earth distance? Shane! That doesn't make sense. Okay. Planets are driven by a secondary ether wind, a vortex centered on the sun that obeys Kepler's third law using the mass of the sun. What is the mass of the sun? And why are the planets over the flat Earth in orbit around that? Oh my gosh. That's insanity.
And then there's another one at 11:34.
Oh, that's too much. What is this table?
God, if I know.
Mercury.
If I know.
We've got units at the top of 10 to the 6 kilometers, and Mercury is 57.9 10 to the 6 kilometers. I don't know, divided by 1 AU, which is 150 million kilometers. Okay, 10 to the 6 kilometers is a million, right? Okay. Equals the number of AUs. Oh yeah, okay, so he's getting the AUs between the Earth and the Sun. And why is he putting this in his flat Earth stuff? It doesn't make sense. Oh gosh.
Yes. But the next one is maybe even funnier. So this was their one of their GPS slides. And I just feast your eyes on this one. Yeah, it's just so
it's the graphic
incomprehensible.
That's got the globe on it.
Yeah. Mm-hmm. Yep.
Pound Repka, no frequency correction needed apparently. What?
The next bullet is my favorite though.
If the concept of reciprocal zenith angle is real, latitude dependent gravitational potential corrections would need to be made. Okay. Deflection to the vertical due to the gravitational potential of the geoid is falsified. If light doesn't require it, how could a plumb bob? Oh my gosh. Linear equipotential vertical gravitational field gradient. Oh my gosh. How could the geometry of T... you got an extra carriage return in there. How could the geometry of E field be the same horizontally on a curved surface? Electrostatics? Oh my God.
This is. Have you seen this one as well? Where he tries to explain why 93 million miles shows up in the what he calls Shane's model.
0.53 degrees. That's the angular size of the sun from the Earth. Does work for a moon. That's not the moon. The moon has a range that's bigger than that. Also work if the sun is 100 times bigger and 100 times as far. Then the sun would be 6 million miles away and 56 million miles wide. What?
56,000.
56,000 miles away. What? 100?
I have to find some more of this. This shit's so funny. Oh, I saved it. Yeah, this is. Oh, thank God! I thought this was lost forever. They deleted it after the debate.
Oh yeah, because they don't their muon thing. They're just like, man. When you went over that, Alan just crumbles, and he did when I talked about it too. It was just a disaster for him.
Well, they don't have any. The problem they have is there's no crackpot scientists that have come up with papers on muons, so they have to make stuff up themselves. And
yeah,
don't mind me reading this. This one's really funny.
But for the audience, they need to know. So one of the tests of relativity is that there are muons that come from high in the atmosphere. Where they come from doesn't matter. People have ideas for why they come from, what happens, but it really doesn't matter. The fact is that muons come from up. They come from somewhere up. And they come from somewhere up in a certain quantity that's rather consistent. Number one. Number two, muons have a half-life that's very well known, very well measured. Number three, that half-life is much too small for muons at high elevations to make it to the surface of the Earth in a linear quantity. So some would, of course, make it because a half-life is a half-life, not an absolute. Everything after the half-life goes away. It's just that the quantity is cut in half after that half-life. So the distance between the top of a mountain and sea level is enough that a muon generally would not make it in high quantities. And then I forgot what one. I'm going to say number D. At sea level, there are way too many muons that are measured in order to match the half-life of a muon compared to the high elevation. And so that's one of the tests of time dilation. And they're like, well, I'll hand it over to you now.
Okay, so yeah, their explanation is beautiful. It was so bad that they deleted it from their website, and Shane refuses to talk to me about it. The detection of more muons than predicted by decay rate theories has been attributed to time dilation. However, this interpretation is considered a reification fallacy. By who? Shane and Alan, I guess. And does not provide conclusive evidence for time dilation. Muons are not fundamental particles, but rather could be disturbances in the luminiferous ether that permeates our flat plane of existence.
Oh my gosh.
In our cosmology, muons are vortices in the ether, created when cosmic rays, I don't know where the hell those come from on a flat Earth, disturb the fabric of space above the flat Earth. These etheric disturbances appear to decay not due to any inherent instability, but because they dissipate their energy into the surrounding aether medium. What mainstream science calls muon decay is actually the process of an aether vortex unwinding and releasing its stored energy. This manifests as flashes of light, misinterpreted as electrons, and subtle aether waves, mistaken for neutrinos. The observed 2.2 microsecond lifetime is simply the average time it takes for an aether vortex of that particular size to fully dissipate. Contrary to relativistic explanations, muons are able to reach the Earth's surface from high altitude not because of time dilation, but due to the aether's natural laminar flow patterns in our flat Earth model. These flow lines act as conduits, allowing aether vortices to travel great distances before dissipating. The behavior of muons provides strong evidence for the aether model in flat Earth cosmology. Their properties align perfectly with what we would expect from disturbances in an all-pervasive aether medium. Wow. That's just beautiful.
That is.
My source is that I made it the fuck up.
Yeah.
That's just.
I love how they're like, it's considered a reification fallacy. By who? Literally, by who?
by them.
It's just
Well, you know,
by them. Yeah.
they have a couple get out of jail free cards, and you know, yelling reification fallacy is one of them. That's amazing. All right. I want to see this one with Marissa. She was so good. She's on, I don't know, I haven't seen her on Twix lately. Maybe she got booted. Is Sirius the only binary star made of two components? Answer, that is not what a binary star is. A binary star system is two stars in orbit around each other. Stars have more than two components anyway, the most common being hydrogen. Oh my God, that's right. And helium. They're stars apparently. But they can also contain oxygen, carbon, iron, and nitrogen. She's getting stars mixed up with the hydrogen and helium. Have you made a rainbow inside with only water and light? Personally, no, I have not, but that is not to say it has never been done. Something about polar pattern inversion. In double rainbows, the pattern of the color is reversed. It's a result of the light being refracted through the water droplets twice. Oh my gosh. She has that, whatever, she can't close her eyes. I really want her to get here, to get back on. Okay, here, this is the muon experiment. Oh yeah, that's a cool one. Did you use that in your debate with him?
Yeah, that was one of Peter's slides. Yeah. He did. Yeah, that was one of the things. We knew that they had. Oh, so I had read their database, and this was the only thing they had on muons. So I knew that they had no hand to play because that was too ridiculous to even bring up in a debate for them. So. Dr. Bennett also had a theory of aether wind, but he at least accepts that muons are real.
Yeah, I mean, he doesn't have quite the severity of problems that they do in that circumstance, right?
Yeah.
Now, some people, in case you're wondering, this is, I think everybody should vote for this guy, because for some reason people are political here on occasion. That's that just for the headgear plus the promise of everybody getting a pony. You should vote for him. Vote for him. There you go. I need to get a boot like that.
Did you see this one? The sun is not hot from Twitter.
I've seen people say that.
So someone asked, how come I can start a fire by focusing the sun rays with a magnifying glass? He says, how come the fire or heat starts after its wavelengths are increased through the magnifying glass before the light source instead of above it closer to the sun?
Oh my gosh. Such a phenomenal misunderstanding of stuff. Just such a childish idea of how things work.
It's incredible, isn't it?
Hey, Toon, you should get a debate going between you and Dallas David.
Who's Dallas David?
That'd be a really fun
I
debate.
think I've heard him on Geo's server or somewhere.
It's Dallas Dave.
That's on Gem's server.
Oh yeah, okay.
There's different Jesus.
There's different Jesus?
That's Flat Earth Aussie Jesus.
Yeah. I don't like him. He's a little too much of a
McToon, I got one
friend of the
final
theory.
question. I promise. Cross my heart. Hope to die. What was your question for me?
You're a flat earther. Your promises are meaningless. So.
What? You can ask me a question now. What was it?
What time, according to Flat Earth, what time will the sun set tomorrow? You picked a location.
That wasn't the question. You forgot the question you had for me?
That was the question I had for you. Yeah.
It had something to do with like breakfast.
Nope. I said, "Are you serial?"
You were asking me about cereal
Yeah,
or something.
I said, "Are you serial?" And yep. But yeah, that wasn't the question.
Oh,
The
about
question,
my map?
about your map. Oh yeah, your hexagon map. Are you serial? That's what the map is. What you think it is?
Yeah, I don't show all of Antarctica around it, just a smidgen here and there, but I'm serious about it. I made it like in 2018.
Yeah.
I used an award-winning Japanese artist map where he depicted all Earth's land masses at a scale of 1-to-1 to each other, where there's no distortion or pooling or squeezing or tucking or.
Okay. And so then, is it good?
And of course, any distortions they say would be in the oceans, where of course, it's easy to hide stuff out there in the deep blue sea.
All right. Sea Lion Prime, there you go. We refer to the yearly movement of the apparent position of the fixed stars resulting from the motion of the Earth around the sun. When flatties claim that make those claims about Einstein, I mean, it just shows how incredibly dishonest they are. It's like Einstein even said that they couldn't measure it. Like, he specifically said they could and gave a couple examples.
Now see if you can make sense of this one, Mike. 1150. Good thing the PhD physicists left. They might have a stroke.
What the? Oh yeah, I've seen this before. They think that light bending near the sun is caused by. Is that what this is?
This is trying to explain gravity as a ether wind effect, I think. Or I don't know what it's trying to say. I think it's something with it might be what you're talking
It's
about.
gravitational lensing. Yeah, they're like they're like general relativity prediction of gravitational lensing, and then they're saying the actual observation, no lensing observed outside the solar limb. The problem is that that's wrong, because there has been lensing observed outside the solar limb all the way up to 180 degrees opposite the sun, because the precision of the measurements using the Shapiro time delay is so precise that they're able to get it nearly 180 degrees away from the sun and still measure the lensing. Very far from where the sun's gases are. But this doesn't help flat Earth, because they don't think that's what the sun is. They don't think that's where the sun is. None of that. So it's a first law of Flurf right there.
Yeah, well, it's part of their Mott and Bailey, right? Argue for geocentrism and then bait and switch to flat Earth without actually making any other arguments.
Yeah, bait and
switch. It's its signature move.
Yeah, he likes to conflate rotation of the Earth with orbit of the Earth, and just that seamless bait and switch. And the thing I wonder, does he know that he's just being super deceptive, or is he so stupid that he thinks it's a real progression of questioning?
I don't know. What do you think, Jesse? You've dealt with that quite a few times.
Oh, what's that? I'm sorry, I was not really paying attention.
Witsit's little orbital to rotational switcheroo that he does.
Orbital to rotational?
Yeah, he talks about how some interferometers, like
yes,
Michelson Gale, could measure.
Right. So
go ahead.
So what was your question about it?
Well, he does a bait and switch. He talks about the rotation that Michelson Gale, interferometers that split the beam and go opposite directions and have inside of the thing an area, and then the amount of measured is proportional to the area, versus and that you get daily, right? You can get the 15 degrees per hour from that. But then he's like, well, then how come they can't measure it using the orbit using an interferometer like Michelson Morley, like kind of this bait and switch style?
Oh, absolutely. And it's just, he's being totally dishonest. And I know this because I had a very intense discussion with him, Alan, Toby, and maybe Shane, I don't remember, about this. And like a few days before he was doing his schooling Globers, where that was going to be, that's the one where he was like, this is basically going to be the end of the globe. He thought that was going to be his grand finale.
Oh.
And unfortunately for him, the only two Globers that showed up for the Glober part was me and Eggshells. And it was hilarious because we headed him off at the pass, and he kept calling for other Globers to join in, but none did for the first bit there. So Eggshells and I had a lot of fun. But yeah, he says, can a Sagnac interferometer sense the motion of moving along a curved path? And he wants you to say yes. What I said was, well, it senses the rotational component, but not the displacement component. Which made him really mad.
Yeah, that wasn't the script he wrote for you.
I know. I went off script. And then, but like you said, and then he says, well, then how come the Michelson-Morley interferometer does not measure Earth's tangential velocity around the sun? So, yeah, he's just being incredibly dishonest, and he knows it, and he knew it before he did the show because I had argued with him about it. And I don't know. Does that answer the question that was asked to me?
Yeah. So I was curious if he was that stupid or if he knew he was that dishonest. And you're saying, he knows. Yeah, he knows. Okay. So yeah, he's, he's posturing for his audience, right? Because he gets bonus points. He gets street cred when he gets to school a Glober in real time.
He gets more Kofi points.
Yeah. Donations to his business. Exactly. Hold on a second. Businesses don't get donations. They get, because donations are
dues. Yes.
Dues. There you go.
All right.
Yeah.
Mike, I've untimed out Blatek on the condition that he confronts you live about his accusation. So if you'd like, I can unmute him.
Ooh. What accusation is it?
That you're a liar, apparently.
Oh, okay. Well, then let me, before you unmute him, I'll just preface this with the same thing I always say. And I know I covered it with him the other day. If anybody thinks that I've lied, then there's only two things you need. You need, number one, to cite where I lied, if you think so. And then number two, provide the supporting evidence. So this wouldn't be just words. You're going to have to, actually provide some external source other than just things you say.
Oh, he just left to go find his source.
Oh!
He was about to get unmuted, but decided, I don't know, maybe he just...
Dang, that's... All right, well, should he come back? That's, it's just the simple, just the base level kind of stuff to do.
Yeah. Maybe he didn't want to do that. Anyway, offers on the table for you, Blatek. So everyone has heard your accusation, and if you have courage, as you say you do, as a warrior against the glasses-wearing commies, you'll come and talk to Mike. Otherwise, you can slither back to the basement that you live in, or wherever it is.
Tell him that if he doesn't come and speak with Mike, that I will be petitioning aggressively to get his timeout started from the beginning again, another whatever the timeout period is.
Well, you kind of said it already, Jesse, so...
Well, let me read a couple things here. Sea Lion Prime, whoever that guy is, he's like, for $2, he says, Flurfs and NDT. Name a more iconic duo. Yeah, the dramatic reading was amazing. Then again, Sea Lion Prime says, get lailed.
Get lailed.
Icy Spin says Chuck Norris could live on Flat Earth if he wanted to. Josh Garver comes in with his third super chat ever that says, what about a third live? A third live. This is my fourth this week. Fourth and final. Then Alyssum says, can gravity work on a flat plane? No. Anything else? No. Thank you for coming to my TED Talk. Also, Marty, there is no functional flat Earth based map. That's true. Nothing at all, Marty. No distances work, even in your 666 sided map.
We'll debate that with Jesse next weekend.
Next weekend. Did you wanna sign up for the marathon next weekend?
Is it any furries in the marathon?
No, it's a furry free marathon to my knowledge.
All right, good.
Though I intend to invite Mallory, though, but who knows if she'll come with furries or feet or something else. Anyway, a week from tomorrow, Friday, the 11th through the 13th, I'm doing a 50-hour marathon to raise money for the trip to Antarctica, where I will film the 24-hour sun and flat earthers watching the 24-hour sun. Thereby proving a bunch of things at the same time, that they lied about the 24-hour sun, and that they lied about not being able to go to Antarctica, and that obviously the biblical claim about their specific interpretation of Isaiah 40:22 is definitively wrong. So anyway, raising money for that.
How is your funding coming along?
About 12,000 right now, out of 40 as my target. So,
do you know what if Critical Think is actually going?
Critical Think and I are talking about things that we're going to be doing there. So it looks to me like he's very certain he will be there.
I didn't know if he was self-funding and hoping to get recovery by his GoFundMe.
Yeah, I don't know his status. And to my knowledge, Globey McGlobeface has stalled and is I don't know his current status, but it's looking like he might not. So.
Well, I'm down for a 90-minute booking. I can.
So, all right. You and Jesse?
Yeah, I think that's the plan, right?
Yeah.
All right. So I sent you C-Line. I sent you the green room, and there's two.
I did. Yes, I did get that.
There's 2 sets on there of Discord. So, whatever you want to. Do you want to arrange those things?
Yeah, I will do that.
All right.
And I just wanted to say. Oh, sorry. Go ahead, Jesse.
I was just going to say, I do have some prior obligations for the weekend, but I don't know which day or what time, and it's not all day, and it's not both days. So we will be playing it by ear a little bit.
We just have an important PSA. I just wanted to say, in Africa, it doesn't matter if you're gay, straight, or bisexual. At the end of the day, it's night.
I thought you were going to say at the end of the day, AIDS is AIDS.
Marty, why'd you go?
You had to go there.
You had to go there.
I work with a guy from Tanzania, and we give him crap all the time about stuff. He's talking about money. I'm like, oh, here's some, just today. I go, here's some money, because he needed money for pop. I'm like, don't drink pop, just have water. And so I tried to give him some Indian rupees that I have on my desk. He's like, he didn't want it. I go, what? That's your money. He goes, we don't use damn it rupees. We use damn it shillings. He says damn it all the time at the wrong time.
Nice.
He left without money for a pop. But he goes, my doctor, damn it, says that I need to have pop at least once a year. And my kid's there with me. I go, you know who his doctor is? Like, what? Who? Dr. Pepper.
Nice.
It's the sweet one.
So New Perspective has uploaded a hit piece against the Globe Gangsters.
Oh.
Perfect.
Oh, darn.
Yeah. Apparently,
sure-
we're anti-heterosexual.
I'm sure it will
Who
go
knew?
well in their echo chamber.
Yeah, I'm sure 500 people will watch it.
Yeah. Did you see Robot Polisher highlighted Witsit admitting to lying?
No.
Yeah, it's a fantastic video. I reposted it on X. I was so
Really?
impressed by it. Yeah.
Oh, that's unusual for Robot Polisher, but
Well, I think he may not have really realized that what he was doing was highlighting Witsit's acknowledging
funny.
that he lied.
You know. Oh gosh.
Oh my god.
I just opened Twitter and I got some fresh derp. I'll just drop it in the chat. I can't.
There's no end to it. All right. Well, I'm going to wrap and pretty soon here and head for bed and stuff. So.
All right. Well, thanks so much, MC Tune, and thanks for Dr. Weasel and Dr. Tony and everyone else who participated. Hopefully it was.
McToon, let me ask you one last question, McToon.
Marty, you interrupted me. Let me finish my.
I apologize.
No class.
All right. So, everyone that participated on the panel, everyone that offered their opinions, Marty, and hopefully it was an educational and fun time, and everyone learned stuff. Do offer people to join the server if you want to have more conversations like this when Mr. Slave isn't here harassing us. So yeah, that's all I have for my side.
All right. Well, thanks a lot for having me. And next weekend, looking forward to coming in for a couple fun times on your server here.
Yeah, I really want to make Rumble Under the Dome happen, but we need to find a suitable pairing.
What's Rumble Under the Dome?
It's supposed to be a bad manners debate between two people that are known to get heated, moderated by Jesse for contrast.
So we're thinking maybe paid NASA shill and who was the other guy? Oh, Blatek.
Yeah, Blatek. Yeah. Or Gary Wybenga would be another one.
Oh yeah. Mabbit would be.
Mabbit! If you could get Mabbit, I'd love to talk to him. He gets madder than Dan.
You know what? Mabbit and Shill would be the best pair ever for this.
And then we have Jesse trying to calm them down and steer them towards reason. No, people will love it.
All right. Yeah, you'd have to keep them. You have to get their language under control a little bit if possible.
Yeah, that's fair.
Yeah, Mabbit is incapable of having a conversation. That's completely true. All right. Well, thanks a lot, Sea Lion and everybody else. We'll catch you all later over next weekend.
Yeah, absolutely. Thanks so much, Mike.
Bye. All right, people. Thank you for joining. This was just a little bit of a... I need to mute them here. There we go. Okay. This was just a kind of a out of the blue kind of thing, kind of cool to analyze the actual like real potential of a infinite plane and applying gravity over it, and that it's hypothetically possible in some sense, but the failures are two. First, the downward acceleration, 9.8 meters per second squared, would be constant everywhere. Doesn't matter how high you are or where you would be, it would have to be the same. And then, but then Flash is like, oh well, there's more mass here and more mass here and less mass here, and so it's not homogeneous. But the problem then is if you have a mass like that, an infinite plane like that, that's not homogeneous, then those small variations will cause the entire plane to then collapse into clumps, multiple different clumps. So The Discord server. Go over to that Discord server. They're pretty cool over there. That is not a Flatty Discord server. And C-Line does a good job keeping things moving along and not just shutting down the the dummies, kind of giving them a chance to make fools of themselves. So anyway, be ready next weekend. Be thinking about the choose your own adventure, if you know what I'm talking about. So all right, and you know what? I'm going to end it not with that same clip, but with a different one. And I hope you all have a great night.
What is a full moon and what is a new moon on your model?
Probably like a magnetic cycle, and just like the center of a barrel cell image of a magnet.
I think it's probably like a magnetic cycle, just like the center of a ferrocell spiral. Image of a magnet, it's just black in the middle. It's actually pure inertia, not just a little. In the ferrocell image of a magnet, it actually goes into its inertial state, then charges back up. It becomes like etherically displaced. Yeah. You start to see it charge up once more, and it goes back like it did before. Once it becomes like etherically spaced, you see it charge up and take its place. Oh, shucks. Ain't that so? That's how moon phases work, fam. Pass the dresser. In the magnet's heart, centrifugal divergence flies, centripetal convergence pulls. Defying all science, etheric whispers sing, light and shadow blend, magnetic cycles spin, where physics seems to end. In the ferrocell image of a magnet, it actually goes into its inertial state, then charges back up. It becomes like etherically displaced. Yeehaw! Grab your partner, swing around, magnetic cycles up and down. Either song in the air, hillbilly science everywhere, cause it's like etherically displaced. Yeehaw! Yo, belly on up to the Wixit word salad buffet. Who has light vinaigrettes? Behind the Jugger Ranch.
Then charges back up, and once it becomes like etherically displaced again, you start to see it charge up throughout a cycle, and it goes back